Hello, hi, namaskar everyone. My name is Deependra and I welcome you all in this one short video of the chapter Permutation and Combination. This is a very straightforward and simple chapter. It can be mastered if you know things logically, if you understand things logically. Along with this, IDJEE asks mainly or mostly simple and easy questions from this particular chapter. So this will give you an add-on or an upper edge in the examination if you master this particular chapter. And in this video, we have this opportunity to cover this chapter completely, thoroughly and comprehensively from all the aspects, whether concepts, learnings, formulae, and yes, we'll consolidate all these things with the previous year's questions. I hope you know that along with this free of cost one-shot video, we are also providing you the DPPs for your practice and the handwritten notes for your revision, that too at no cost. All of this can be accessed by you by clicking on the link given in the description box. The link will redirect you to our PW app from where millions of students are already preparing for different competitive exams. So without further ado, let's get started. First of all, let us see what all we'll be covering in this particular one shot. So of course, we'll begin our discussion with factorials. What are they? Basic principle of counting, addition, multiplication, and OR. And then we'll talk about exponent of a prime. So in a factorial, we'll talk how times a prime is appearing. A very interesting trick is also we're going to discuss. We'll be discussing in this particular part. And then of course, we'll come to permutation. And then we'll come under this part where we'll discuss arrangement under constraints. So this is the most important topic from this chapter. So of course, this will lay the foundation for this topic and this will become one of the most important topics. Then of course, we'll talk about circular permutation and then we'll talk about combination, the second most important topic from this particular chapter. Then we'll move towards selection and division and distribution of distinct items. Of course, we'll talk about division of identical items as well, and then we'll talk about dearrangement and some problems based on dictionary and ranking and all, and some other methods as well. So this is all what we'll be discussing in this particular single one short video of permutation and combination. Let's get started. First of all, please understand whenever you use the word and, of course, it is a conjunction and it should be used wisely. So whenever in a problem, if we are using the word and, we use the multiplication sign. Now, what do I mean by that? I'll try to explain it logically. For example, let's say I have these two stations. Let's say there is a city named as Bhopal in Madhya Pradesh, right? And there is a city named as Indore again in Madhya Pradesh. And between Bhopal and Indore, there is a small town labeled as Asta, right? So now let's say I'm discovering some options. And after discovering certain options, I'm reaching to a conclusion that from Bhopal to Asta, there are three ways. So there are three ways through which I can reach from Bhopal to Asta. And I repeat, and from Asta to Indore, there are two ways. So from Asta to Indore, there are two distinct ways through which I can reach from Asta to Indore. Now, if I were to ask you how many choices do I have from Bhopal to Indore? So the total number of distinct ways, how many they are, if I am willing to reach to Indore from Bhopal, you would say, sir, you have basically 6 choices. How am I reaching to this conclusion? See, this way, or I could choose this way, or I could choose this way, or I could choose this, or I could have chosen this way, or I could have chosen this way. So are you realizing with each of these ways, I have 2 choices. And how many choices do I have here? 3. So total number of ways are going to be 3 into 2. In a very simple language, if I'm using the conjunction and, I'll use the multiplication sign. So from Bhopal to Asta, there are 3 ways. From Asta to Indore, there are 2 ways. So the total number of ways from Bhopal to Indore will be 3 into 2, that is 6 ways. So did you understand this part, students? So from Indore to Bhopal to Indore, if I'm asking you the total number of ways, it will be 6 ways. Did you understand this principle of multiplication? Similarly, there is a principle of addition as well. So whenever you see the word or, whenever you use the conjunction or, you replace it by addition. What does it mean? For example, let's say from here, in this case, let's say, again, let's take the same example, Indore, and then there is a town Asta, and let's say this is all what we have. So from Indore to Asta, let's say, how many choices do I have? Let's say I have 2 choices. So I can choose either this way or this way. So I can choose either this way, which is one of the ways, or this is the second way, which is another way. Let's call it another way. So I have 2 choices. So from Indore to Asta, if I were to ask you how many choices do I have in a very simple language, you will say, sir, 2 choices. You can choose either this way or this way. So when you're using the conjunction or, what you do is you add. So this choice, which is a choice, one choice. This is another choice, which is also a one choice. So I'll say 1 or 1, which means 1 plus 1. Always remember this as a conjunction, that throughout this chapter, permutation and combination, whenever we are using the conjunction or, I'll be using the addition, the plus sign, and whenever I'm using the conjunction and, I'll be using multiplication sign. I hope there is no confusion on that. Moving ahead towards the next part, let's seek more clarity on this basic principle of counting through this particular example. This was a question asked by JEE Mains in 2025. Let's read it first. So what does it say? It says the number of 7-digit numbers. So okay, there will be 7-digit numbers such that sum of their digits is even. Sum of their digits is even. Okay, that's fine. And it is told to be m into n into 10 to the power n. Okay, where m and n are basically any digit basically from 1 to 9. Okay, that's fine. Then we are asked the values of m plus n. This is all trivial. Let's focus on this part, the first part of the question. If I could crack this part, I think the other part, the second part of the question is easy, which can be cracked. But first part, what about the first part? I'll say the number of 7-digit numbers. So can you help me with the least and the largest 7-digit number? So if I were to ask you the smallest possible 7-digit number, you will say, sir, it will be 1 followed by 6 zeros. Do you all agree with this? That it should be this number only. Even if I don't put commas, this will be the smallest possible 7-digit numbers, because there are 6 zeros in this one. What about the largest possible 7-digit number? This was a 7-digit smallest possible number. If I were to ask you the largest possible 7-digit number, you will say that it will be 9999 followed by other set of 3 nines. So these are 7 nines, and this will be the biggest or the largest possible 7-digit number. Now I'm asking you to pay an attention on this part, that when you talk about sum of the digits to be even, why are you not recognizing that alternatively the numbers will be giving you the sum of the digits to be even and odd? What do I mean by that? Let's take another example. Let's say I have a number 1, 2, 3. What is the sum of its digits? Sir, 3 plus 2 is 5, 5 plus 1 is 6. So this gave me sum of the digits as even. Now, will you not agree or say, sir, the next number, which is 124, will give you an odd sum, because 4 plus 2, 6 plus 1, 7. And it was bound to happen because from 3 we have reached to 4. So this sum will be odd. And again, if I talk about 125, it will again give me even. So technically, will you not agree that alternatively, I'll keep getting the sum of the digits as even and odd? So in a very simple language, they are asking us to calculate half of the numbers here, because half of the 7-digit numbers will give me the sum as even, and half of the 7-digit numbers will give me some of the digits as odd. So are you realizing I simply need to calculate half of the numbers? How easy this question is. Did you understand the approach? So if now I'm asking you to give me the number of numbers here present over here, so you will say, sir, upper limit minus lower limit plus 1. Do you remember that? Let's say if I'm asking you to count all the numbers from 2 to 8. So from 2 to 8, let's say 2, 3, 4, 5, 6, 7, 8. So these are all the natural numbers from 2 to 8, including 2 and 8 both. How many are they? So one of the ways is you manually counted 2, 3, 4, 5, 6, 7, 8. Or the other way is that subtract the lower limit from the upper limit and add 1 to it. So 8 minus 2 is 6 plus 1 is going to be 7. I hope you are understanding it. So there are basically 7 digits or 7 numbers. Did you understand this whole process? Are you able to make some sense out of it? Why are we discussing this step or this part? Because I want you all to understand that here also we'll be using the same logic. So upper limit minus lower limit plus 1, right? So how do I do that? I'll simply do it like this. So from upper limit minus lower limit, I hope you know the difference is going to be 8, 9, 9, 9, 9, 9. How many nines do I need to write? 6. So these are 5. And plus 1. So if I am adding plus 1 to it, I hope you're realizing it is going to be 0, 0, 0, 0, 0, 0, and this will become 9. So it is going to be 9 followed by 6 zeros. So basically, these are the numbers which will give them the sum of the digits as, basically these are the total numbers first of all, between the largest 7-digit number and the smallest 7-digit number. These are the total numbers lying here. But out of this, half of them will give me the sum as even, and the other half will give me the sum of the digits as odd. So I need to take half of it. I hope you're understanding now. So if now I am taking the half of it, what will it give me? I hope I need not tell you. Half of 90 is 45. The other zeros will remain same. So 45 is followed by how many zeros? 5 zeros. Did you get that part? So 45 is followed by 5 zeros. I hope everyone is comfortably understanding this. Now let's come to this conclusion. 45. We know 45 is basically 45 is 9 into 5, right? So 45 is 9 into 5. So I'll write it as 9 into 5. So 9 into 5 and of course into 10 to the power 5. Why am I writing it like this? Because see, if there was an n here, there is an n here as well. So I hope you can see that this 5 over here can be treated or compared with that n, and this 9 will be that m. What are we asked? We are asked the value of m plus n. M plus n is going to be 9 plus 5, which is nothing but 14. Are you realizing this is how easy questions are going to be asked from this particular chapter? Not all the questions are going to be this easy. Of course, some will be tricky, but they will become easy once you understand the concept. So I hope you're understanding that chapter is easy. Logically, if you know things, you can crack the questions very easily. I hope you are getting this idea very clearly. Let's say in the examination hall, you forget how to count the number of numbers lying between these two numbers. So take a smaller sample space, build a logic on that, and then apply the same logic on this. For example, when I asked you to calculate the number of numbers between 2 and 8, we build a logic, and once you have built a logic, you can apply that same logic on this bigger data space, and the same logic will work here as well. Did you get that point? Now, if I move further, let's talk about the next part. Let's understand what is a factorial. So factorial is basically the product of first n natural numbers. For example, if I'm asking you 5 factorial, so it means product of first 5 natural numbers. So 5 into 4 into 3 into 2 into 1. That basically gives you the factorial. I hope you'll remember it. Along with this, when n is negative or a fraction, then factorial is not defined. So factorial is defined on the whole numbers only. 0 factorial is 1, 1 factorial is 1, 2 factorial is 2 into 1, 3 factorial is 3 into 2 into 1, and that's how. And at least up till 10 factorial, you should have these values at your fingertips. 1 factorial will be 1, 2 factorial is 2, 3 factorial is 6, 4 factorial is 4 into 3 factorial, which is 4 into 6, 24, and so on. So up till 10 factorial, you should have these numbers at your fingertips. I hope you will remember them. Now, moving ahead. This is a very standard property. Let's say if I'm asking you n factorial, can you not say n into n minus 1 factorial as we have already discussed? Let's say if I'm asking you the value of 5 factorial, will you not say, sir, it can be written as 5 into 4 factorial? So that's what they are trying to say. Similarly, always remember this also as a result that 0 factorial or 1 factorial, they are always 1. And yes, 2n factorial, it can be written as 2 to the power n into n factorial into all the odd numbers product. This can be simplified through a simple expansion. You can do it by yourself. And similarly, remember, n factorial upon r factorial will give you this, where r is less than n. It is a very simple phenomena. Let's say I'm asking you 5 factorial upon 3 factorial. What will you say? Would you not say, sir, 5 factorial is going to be 5 into 4 into 3 factorial divided by this 3 factorial. So here 3 factorial is cancelled and you're left with 5 into 4. That is exactly what they are trying to give you through this particular formula. So I hope you'll remember these results. Moving ahead, the same result is getting applied here by the same logic. This is something I wish that you write or remember. 1 upon n factorial plus 1 upon n plus 1 factorial is always lambda upon n plus 2 factorial. What is lambda? Lambda is n plus 2 whole square. So I'm requesting that you remember this result. This will be very useful for you. Similarly, this is also something where students commit a lot of errors. Let's say you're given x factorial is equal to y factorial. Then will you always state that x and y are equal? That's again wrong. So as soon as you see x factorial is equals to y square, x factorial is equals to y factorial, don't be in a rush to conclude that x and y are equal. The other possibility could be, yes, x and y could be equal, or the next possibility could be x could be 0, y could be 1. I hope you're realizing why. Or y could be 0 and x could be 1. That's the other possibility. So take care of such nuances. Now, we'll talk about the next concept, which is called exponent of prime p in n factorial. What does it mean? Let us analyze 13 factorial. What do you mean by 13 factorial? So 13 factorial is going to be 13 into 12 into 11 into 10 into 9 into 8 into 7 into 6 into 5 into 4 into 3 into 2 into 1. Let's say I am talking about a prime and let's call that prime to be 3. So if I were to ask you how many threes are there, what would be your response? You would say, sir, I could find a 3 here, second one here, third one here, fourth one here. So I could find 4 threes here, which means 3 to the power 4 was there. But I'm committing an error. When I'm saying that every third number will contain a 3, so does it ensure that you have counted all the threes? I think I'm committing an error because 9 basically was 3 square. So it did not have only one 3, it did have two threes. I hope you're realizing it. So again, it had one more 3. Did you get that part? And that's how the number of threes in this particular 13 factorial will be 3 to the power 5. So if somebody asks me that how many threes can perfectly divide 13 factorial, I'll say the highest power of 3 which can divide 13 factorial will be 5. I hope you're realizing why. But sir, do we always have to calculate it like this? Can there be a shortcut for this? So I'm sharing the shortcut directly. Straight away learn it and apply it whenever such questions asked in the exam. So what is that shortcut? What is that logic? The shortcut says, let's say I'm asking you the number of threes in 13 factorial. What is the highest power of 3 in 13 factorial? So first of all, divide 13 by 3 and write the quotient without decimals. So 3 into 4 is 13. So take its GIF. So 13 when divided by 3 is 4 point something. Take its GIF, take the integral part of the quotient, which is 4. Now, look at this 4. Is this 4 still greater than 3? Yes. Divide it one more time. So 4 when divided by 3, again take its GIF. So 4 when divided by 3 gives you 1 point something. Again, I'll take its GIF, which means 1. This 4 and this 1 when added, 4 plus 1 is basically nothing but 5. 4 plus 1 is nothing but what? 5. So I'll have the highest power of 3 available in 13 factorial to be 5. So 3 to the power 5 or 5 threes are definitely going to be there. Did you understand this logic? Are you able to get my point? And are you understanding this short technique? I hope you'll take a note of it and you will remember it. For example, look at this particular question. JEE Mains, such an easy question as asked by JEE Mains in 2025. The largest natural number n such that 3 to the power n divides 50 factorial. I hope you must have this algorithm in your mind. Sir, I'll divide 50 by 3 first. What do we get? So I hope you understand that 3 1 times is going to be 3, remainder is 2, that is 20, and 6 times is going to be 18. So 16. Now again, 16 is greater than 3. So I'll again divide 16 by 3. So what do I get when I divide 16 by 3? 16 by 3. 3 into 5 is 15. So I get 5. Again, we have found 5 which is greater than 3. Again, I'll divide 5 by 3. So 5 by 3 gives me 1 as quotient. I repeat, I'm taking the integral part only. So 5 upon 3 is 1 and that is going to be the last number because 1 is not divisible by 3. It will give me a decimal or a fraction less than 1. So these are 16, 5 and 1 will be the powers or will be the threes I'll be having. Single threes will be 16. In terms of square, there will be 5 more and in terms of cube, there will be 1 more. I hope you're realizing at 9, 18, there I'll be getting more 2s and at 27 and all, I'll be getting more 3s. Sorry. At 9, at 18 and all, I'll be getting more 3s and at 27 and all, I'll be getting more 3s. So I hope you're understanding. Single 3s will be 16, double 3s will be 5 and single triple 3s will be 1. So I hope you're understanding. Total number of 3s which I'll be seeing will be 16, 5 and 1, which when calculated gives you 16 plus 5 is 21 plus 1 is 22, which means option B is needed to be marked correctly. Are you not realizing how simple this chapter is, how easily you can master it, and how easily you can mark correct options from this question? As already mentioned, easy questions are going to be asked from this chapter. It is a logically very simple chapter. If you know the concepts, you can crack the questions very easily. So learn all the concepts, master all of them, learn these short tricks and techniques, and you can crack the questions with these simple steps. Are you not accepting and realizing it? Now, let's move ahead towards the next question. Let us understand the principle of inclusion and exclusion. What does it mean? Let's say I have two sets, A and B. They are finite sets. And through Venn diagram, I can represent them like this, that there is a universal set This is set A and this is set B. Now, what if I ask you A union B? Will you not say, sir, A union B means that you are wanting to have this region, this and this. This is what I'm wanting to have. I hope you are comfortably understanding it. So A union B can be written as, I hope you remember, set theory. In set theory, we have understood it, and we had a discussion on this, that will talk about principle of inclusion and exclusion in permutation and combination. So this is exactly where we are discussing it. In the last lecture only, sets, relation, and functions, we had a discussion on this. Do you remember that? So number of elements in set A will be this, number of elements in set B will be this. But when you include the number of elements of A, when you include the number of elements of set B, the elements in set A and B both are counted twice. But I needed them only once, so that's why I am excluding it. So inclusion and then exclusion. What if there are three sets? Then inclusion, exclusion, inclusion. The logical proof is also discussed in the chapter sets only. So if you are getting confused, what is it? We have had a discussion, a thorough discussion in that chapter as well. So don't worry about it. You can watch that part as well. But although for the sake of revision, for the sake of completing it here as well, I am retelling you the formula. The formula is, let's say there are three sets. So set A, set B, and set C. And if I want to calculate A union B union C, this is what I wish to calculate. I hope you remember, I can calculate it with number of elements in A, number of elements in B, number of elements in C, some of these. But when you do so, I hope you're realizing that this is counted twice, this is counted twice, and this is counted twice. So I need to subtract them. So when you subtract A intersection B, B intersection C, and C intersection A, then what happens is, this which was initially counted thrice with A, B, and C is also eliminated thrice with this, this, and this. So I need to have it. So when you wish to have it, you need to add A intersection B intersection C. I hope the logical proof is also understood by you all, that the phenomena is very simple. Initially, you include single ones, then you exclude double ones, and then you include triple ones. So inclusion, exclusion, inclusion, and that's on. That's how you keep going on. Let's say there were four sets. So single ones are included, double ones are excluded, triple ones are included, and all the four ones are excluded. So inclusion, exclusion, inclusion, exclusion. That's how you count the number. Did you get that part? I hope there is no confusion on that. You are comfortably understanding it. Similarly, they are generalizing it on n number of sets. So there are, let's say, n number of sets whose union we are willing to take. How will I do it? First of all, I'll count the number of elements, the sum of number of elements in single one of them, individual one of them, A1, A2, A3. Then I'll take two of them and then I'll subtract that result. Then I'll take three of them and then I'll add that result. Then I'll take four of them and then I'll subtract that result. So inclusion, exclusion, inclusion, exclusion. And that's what you call the principle of inclusion and exclusion. Did you get that part? Did you understand it thoroughly? And if you have understood it, let us move ahead. And now let's talk about the concept of permutation. What does it mean? Let's say there are three friends of yours. I'll just try and tell you the difference between permutation and combination through this very simple example. So you have three friends, let's say Yash, Pratik, and Deepak. So these are the three friends of yours, right? What you do is you plan to go for a movie. You plan to go for a movie and you have only 3 tickets, where you are also willing to go for the movie along with 2 of your friends. Why can't you go with 3 of your friends? Because the problem is that you have only 3 tickets, including yourself as well. So you can choose any 2 friends. So here the problem is, I can go with any 2 of my friends technically. So I have basically these choices. These choices, I can go with Yash Pratik, I can go with Yash Deepak, or I can go with Pratik and Deepak. Do you think that it would matter that if I go with Pratik Yash? Because Yash Pratik and Pratik Yash are same. If I say that I'm going for the movie with Yash Deepak or Deepak Yash, it would be counted at same scenario. If I'm saying that I'm going for the movie with Pratik and Deepak or with Deepak or Pratik, that will be counted as the same scenario. So remember, when you are talking about calculating the number of cases and the order doesn't matter, and if the order doesn't matter, then such scenarios are said to be the questions or scenarios of combination. When only selection matters. What was the problem here? That out of 3 available choices or friends, I was supposed to choose 2 people. So if I'm supposed to select only, then it is a problem on combination. But let's say instead of going for a movie, we are getting a photograph clicked. And there are 2 chairs placed over here. 3, of course. Let's say 2 chairs are placed over here. Out of 3 friends, Yash, Pratik and Deepen. So I can click Yash, Pratik and Deepak. I can click only 2 persons at a time, let's say in that frame. That's the constraint. So now, do you not think that the order matters? Because one of the photographs may have Yash on the left, Pratik on the right, and the second photograph with the same persons may have Pratik on the left and Yash on the right. So here, the order matters. Why? Because no matter whether you choose Yash Pratik or Pratik Yash, here, what is the case? That Yash was on the left in the first scenario, and in the second scenario, Yash is on the right. So that's the case which you need to pay attention to. That here in this particular case, the order mattered. The arrangement mattered. So selection was there, but after selection, after choosing them, I arranged them. So when it is limited to arrangement only, when it is limited to selection only, then you call it a problem on combination. Then we call it a problem on combination. But when along with selection, let's say arrangement also come into picture. What do I mean by arrangement? Let's say Yash Pratik or Pratik Yash. The second selection was Yash Deepak, so I could have asked them to sit like this, or they could have sat like Deepak and Yash in this manner, or I could ask Pratik and Deepak to be featured for the photograph, but they could have placed like Deepak Yash, Deepak Pratik, or Pratik Deepak. So in that case, there are 6 choices. So combination is simply selection, but permutation is selection and then arrangement. So whenever arrangement comes into picture, you call it a problem of permutation. I hope you're able to differentiate these 2 terms. So first of all, I hope permutation is very well understood by you all. Now, when I say that if out of n available objects, I need to make r arrangements. In this last scenario only, how many friends did I have? I had 3 friends. Out of 3 available friends, I needed to make arrangements of 2 persons. 3 choices, Yash, Pratik and Deepak I had. But out of those, only 2 persons were supposed to be permutated, which means 2 persons were supposed to be arranged. In how many ways can I do it? So out of 3 people, 2 people or 2 persons can be selected and arranged in 3p2 ways. That's a direct formula. How do you expand this formula? The formula is pretty simple here. 3p2 is written as 3 factorial upon 3 minus 2 factorial. I hope you're understanding this formula. So what is 3 factorial? 3 factorial is basically 6. 3 minus 2 factorial is 1, which is 1 factorial, which is 1. So the number of ways were 6. I hope you had this scenario here. 1, 2, 3, 4. What is happening here? 4, 5, and 6. So these are the 6 scenarios. What I'm trying to make you understand is that in the chapter permutation and combination, you need not draw all these possible scenarios. But this chapter actually helps you in calculating the number of scenarios. So I hope you are very much comfortable with this formula. So something very crucial you need to remember, that here this expression NPR is going to be n factorial upon n minus r factorial. That means out of n objects, r objects permutation can be done in NPR ways, which is n factorial upon n minus r factorial. Did you get that part? Did you understand this part? If you have, let's talk about more results. For example, let's say I have n choices and I have n places. Let's say this time for the photograph, I have 3 chairs and I can make all of them sit on those chairs. So if I have 3 chairs and if I could make all of them sit on those 3 chairs, so first person, if I ask him how many choices does he have, he'll say I have 3 choices. The second person will say I have 2 choices. The third person will say I have only 1 choice, which means here it is a problem of permutation of 3 objects out of 3 objects. So 3p3 will be basically nothing but what? It will be n factorial upon n minus n factorial. So 3 factorial is 6. Sorry. Yes, 3 factorial is 6 and 3 minus 3 is 0 factorial, which is 1. So here also the number of cases will be 6. If you are getting confused, let's say Yash, Pratik, Deepak, Yash, Deepak, Pratik, Pratik, Yash, Deepak, Pratik, Deepak, Yash, Deepak, Pratik, Yash, Deepak, Yash, Pratik. So these are those 6 scenarios. Although the advantage of P and C is that you need not calculate them manually. Rather, you can do it like this and get your results very easily. Did you get that part? Now, let us move ahead. Some formulas, some standard results you need to remember. NP0 and NP1. NP0 is always going to be 1. What does it mean? The number of ways in which 0 objects can be arranged out of n objects will be 1. That one way in which you did not arrange anything. So that is also a way, right? So NP0 will be 1. What about NP1? It is going to be n. So out of n objects, if I'm supposed to select and arrange only one object, well, that will be n number of ways. Similarly, here, please remember, whether you talk about NP n-1 or NPn, coincidentally, it will be n factorial. If I could move towards the next concept, it will be this formula that NPR can be written as n times n-1 PR-1. You can have this result along with you because questions are formed on these properties as well. Sometimes they may not give you a verbal or word problem, but they may give you an expression based problem like this, and then you need to use these formulae or result. Whatever you have, whatever you don't have, whatever you keep with yourself, just do remember one thing, that NPR is always going to be n factorial upon n minus r factorial. That is something which is true. And yes, r should always be less than n. That should be a very simple thing which should be remembered and understood by you all. There is one more result which is something again relevant to the formula only. NPR is n minus r, n minus 1 PR minus 1, some basic expansions. And on the basis of this only, this and this result can also be generated. Apply simple formula and these formulae can be worked upon. Now, there is one more result. This is something very crucial. Let's say I have a word. Let's say I have the word mathematics. So I have the word mathematics, right? So this mathematics word, let's say I have this word mathematics and I want to rearrange the letters of this word. So how many letters are they? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So there are 11 letters. So I would say, as per the logic we have discussed, 11 letters at 11 places can be arranged in 11 factorial ways. Do you remember that? But the problem is, sir, objects are not identical. Sorry, objects are not distinct. All the objects are not distinct. Some are identical. For example, if you look at M, so M has appeared twice. So now arrangement of these two M are additionally counted, which wouldn't be there. I hope you're realizing this. Whether you place this M here and this M here, or this M here and this M here, that will be the same case. But in that 11 factorial, we have counted it additionally. So I need to remove those results. So in order to remove it, I need to divide it by 2 factorial. I hope you're understanding it. So again, if I look at number of A's, that A is also getting repeated, one here and the other one here. So 2 A's are there. So again, I need to divide it further by 2 factorial. Are we seeing anything else also getting repeated? We are seeing that this T here and this T here also is a type which is getting repeated, and that is getting repeated twice. So I again need to divide it by further 2 factorial. Is there anything else which is also getting repeated? I think H, E, I, C and S are appearing only once, so I need not do or anything further. So this will be the number of arrangements of the letters of the word mathematics where M, A and T were appearing twice each. Did you understand the formula? That's exactly the formula says here. I hope this example has given you a complete clarity about this. If you have gotten this, let's understand a question here. What does it say? So here they are asking you the number of sequences. So they are not asking you the numbers. Mind you, they are not asking you the numbers. They are asking you the sequences. They are asking you the sequences. Read this question carefully. Now, of 10 terms. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I think 10, 3, 3, 6, 3, and yes. Which are either 0, 1 or 2. Which are either 0, 1 or 2 that contain how many? Exactly 5 ones. So 1, 2, 3, 4, 5 ones are there. Exactly 3 twos. So 1, 2, 3 twos are there, which means exactly 2 zeros should be there. So exactly 2 zeros should be there. Had it been a question of calculating the number of numbers, I would have said, sir, at this position, I cannot have a 0. Because a number cannot begin with a 0 if it is a 10-digit number. I hope you're realizing why. But here, they did not say that it should be a number. It should be a sequence. It should be an arrangement of digits. And if it is an arrangement of digits, I need not bother here, which means I can have a 0 here. Did you understand the advantage here? I hope you are able to differentiate numbers in sequence. So here, I'll say I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 numbers. So 10 digits can be arranged in how many ways? I'll say it's a 10 factorial ways. Out of these 10 factorial ways, 1, 2, 3, 4, 5. So 1 is appearing 5 times, and 2 is appearing 2 times, 2 is appearing 2 times, and 0, sorry, 2 has appeared 3 times. I'm really sorry. And 0 has appeared 2 times. So did you understand this entire question? The catch here is it is not a 10-digit number, it is a 10-digit sequence. I hope you know how to expand this, simplify it, and get the answer, which you can do by yourself. And do write your answer in the comment box. I'll love to read your responses. Right now, I hope you are able to understand these formulae, these concepts. Another important result: the number of permutations of n different things taken are at a time when each thing may be repeated any number of times is n to the power r. Can you not relate it with the concept we have learnt in the mapping of functions? Let me take the example of functions again. This is a set A which has, let's say, elements A, B, and C. This is our domain set, right? Now, there is a function f which is applied on this, and this is the set B, which is your codomain set, right? And this set has, let's say, 4 elements D, E, F, G. Now, I am asking you that how many mappings are there? No constraint is there. How many functions can be created from set A to B? So function has domain as A and codomain as B. So what is the number of functions we can create? Distinct functions. So I'll simply approach this A. Let's treat A as a person and D, E, F, G as chairs. And if I approach A and ask him that in how many ways can you occupy, the seats? So A would come up with a response saying that I have 4 choices. I can be mapped with either D or E or F or G. So how many choices does A have? So A will say I have basically 4 choices. Did you get that? Now, when I approach B, would B also not say the same thing? Because there is no constraint. It can be many one, right? So when I ask B, the B also has 4 choices, D, E, F, G. And similarly, when I ask C, C again has 4 choices, either D or E or F or G. So here, this C also has 4 choices, which means total number of distinct functions which I'll be able to create will be 4 cubed 64. My point here is that if I have n different things taken r at a time, then each thing may be repeated any number of times, then such arrangement will be n to the power r, as you all can see. Questions are formed. Let's say I have 4 fingers in my hand. Usually we have 4 fingers. We all, not all are Hrithik Roshans. So even that's a thumb basically. So let's say I have 4 fingers in my hand and I have certain number of rings. So in how many ways can I wear them? No constraint is there that one finger cannot have more than 2 rings or something like that. So there you need to again categorize that which part represents this and which part represents this. Let's say there are 4 monkeys and 3 persons. So in how many ways can you assign those monkeys to persons where you don't have any constraint that a person cannot have more than 1 monkey? So again, that is something where you use this particular concept. So such questions are asked and you need to use this very basic concept, the concept of assigning, right? Now, moving ahead towards the next concept says that here, the number of permutation of n different things taken are at a time when a particular thing is to be always included in each arrangement is this. I'll try and make you understand it, this particular data through an example. All of this through an example, through a question. We'll talk about a question only. Don't worry about that. I have deliberately kept a question on all those cases where you put certain constraint and conditions and then you talk about permutations. We'll talk about that through a question. Don't worry about that. Rather than telling you a formula and making you learn that, no, that is not going to work in PNC. You should understand things logically. Because my teacher of mathematics in Kota used to say that a person's ability of being logical, a person's ability to, being more, being logical only, can be understood that how easily he deals with the problems based on the chapter permutation and combination. Because it requires being logical. So when you are logically sound, when you know how to understand a problem and apply the learnings, there you can be treated as a logically sound person. So of course, this is a chapter where logic is assessed, where your logical ability is assessed. So the more logically sound you are, the ease, with more ease you can treat or deal with the problems. So I hope you're understanding this chapter is not a chapter of learning and memorizing a lot of formulae. This chapter is basically more of understanding and applying them. So understand and apply, and that too will do through questions, right? So rather than giving you different formulae, I'll make you understand those concepts through questions. So don't hesitate about that. Here, when you talk about circular arrangements, let's say there are 5%. Let's say there are 5%. So the problem is previously, let's say there was a linear arrangement and I am asking these 5% A, B, C, D and E to sit at these 5 chairs. I would have said the number of arrangements could be 5 factorial. But the problem here is that let's say if 5 persons are asked to sit on this circular arrangement, let's say if I make A, B, C, D and E sit like this, and I'm looking at this from top, or even if the arrangement goes like this, that when I say that A sits here, B sits here, C sits here, D sits here and E sits here, that will also look identical because it is a circular arrangement. All the chairs are same. So here, even A, B, C, D are placed like this, or A, B, C, D is placed like this, that will look same. So here, circular arrangement has this one thing gets subtracted or eliminated, and then you write the circular arrangement of 5 objects as 5 minus 1 factorial. Although a better logical explanation we'll discuss in a straightforward longer video, but here I'm directly giving you the formula that if I'm asked to arrange n objects around a circular table, then the number of arrangements will be n minus 1 factorial. I hope you're understanding the reason that arrangements are counted double here. That's the scenario through which you'll get more clarity about it. So here, this is what you need to understand, that if n objects are to be arranged in a circular fashion, then it will give you n minus 1 factorial arrangements. But again, there is a catch. So what is the catch? The catch is, let's say if I'm given, let's say a flower, right? So this is the flower and it has, what should I say? A garland is there. And this garland is made up of 4 flowers, A, B, C, D. Now, I can treat this garland like this when I'm arranging it in a clockwise manner. So if I arrange it in an anti-clockwise manner, A, B, C, D, then also this remains the same garland. Why am I saying that this is still a same garland? Because if I take this garland and flip it, it will become this only. So whenever you deal with questions based on garland or something like that, then also you will say, sir, circular arrangement will be n minus 1 factorial, but the cases will be halved. The cases will be halved because in the cases of garland or something like that, there you need to understand that clockwise arrangement and anti-clockwise arrangement should not be counted separately. So in that case, you need to multiply it by 1 by 2. You should half the number of cases. I hope you're understanding the logical reason and explanation behind that. Did you get that part? Now, this is exactly what I was trying to make you understand. Half of n minus 1 factorial. Now, moving ahead, the next case where you are again given certain cases, we'll talk about these cases through questions. So don't worry about that. We will have a discussion on this. So don't hesitate in that. We'll talk about this as well, but the logical explanation we have discussed already. Look at this particular question. These questions will give you more clarity about those formulae which we avoided or skipped discussing. We'll discuss them through these questions only. I'll give you the logical approach which you should remember. What does the question say? The question says that the number of ways in which 5 girls and 7 boys can be seated at a round table so that no 2 girls sit together. So if I want the girls to be not sat together, is there any constraint on boys? No, boys can sit together. And of course, the number of boys is more. In that case, boys are bound to sit together. But what I need to ensure is that the girls don't sit together. Okay, so let's have a circular arrangement here. Okay, so I am having a circular arrangement here in which I am having 7 boys. So first, let's make these 7 boys sit on this circular arrangement at this circular arrangement. Let's say this is boy 1, then you have boy 2, then you have boy 3, then you have boy 4, then there boy 5 sits, then this is boy 6, and that's your boy 7. So these are 7 boys, right? Lately or recently, I was watching this movie, Zindagi Na Milegi Dobara. So, 7 boys are there, right? So, 7 boys at 7 places, but in a circular fashion, can be arranged in how many ways? I hope you remember 7 minus 1 factorial, which in a simpler language can be written as 6 factorial and. I hope you remember the conjunction and means multiplication. And now I have created these separators. The boys are behaving as separators. Now, after I have made these boys sit, these places, which now I am left with, can be defined uniquely. Can be defined uniquely. So if someone is thinking that, sir, is it still a circular arrangement? No, this is not a circular arrangement, but this place is defined uniquely. This place is the place which is the left of B2 and which is the right of B4. So every single place can be defined uniquely. This is not like a circular arrangement anymore for these girls now. So now for these girls, I am left with 1, 2, 3, 4, 5, 6, 7 choices. So out of 7 choices, I need to make these girls sit at 5 places. So out of 7 choices, 5 choices can be selected in 7C5 ways. The way we deal with permutation, in the same fashion we can deal with combination. Permutation is selection and arrangement. Combination is selection only. I hope you remember. So out of 7 choices, I have selected 5 choices, 5 seats. And at those 5 places, I'll make those girls sit, which is 7C5 into 5 factorial. If you are not able to understand this part, you can very simply say, sir, out of 7 available choices, at 5 choices, I can make these 5 girls sit in 7P5 ways. And again, this is something which you already know how to expand it, and you can mark the correct option accordingly. My concern was to make you understand that how can you deal with different scenarios based on permutation and combinations. So are you able to make some sense out of it? Are you able to understand that how should you deal with questions based on permutation and combination? And what all you should keep in mind? What is the logical approach? So the logical approach is that girls are separated. Girls are to be separated. So what I'll do is I'll make these boys sit. So boys can sit in 6 factorial ways. 7 boys in 6 factorial because it is a circular arrangement. But once boys are settled, now the arrangements will be unique. It will not be treated as a circular arrangement. So now I have 7 places. Because if I make these girls, 5 girls sit at these 7 places out of 5 places out of these 7 places, then of course no 2 girls will be together because boys are behaving as separators, right? So now at these 5 places out of 7 available places, 5 girls can be asked to sit in 7P5 ways. I hope you know how to expand 7P5. You can expand it and finally get the answer and mark it correctly. Did you understand the whole question? Do I need to explain it further? Now, permutation is over. Let's talk about combination. So what do I mean by combination? What is it? Let's have a discussion or a detailed discussion on this, right? As we have already discussed, permutation is all about selection and then arrangement, and combination is all about selection only. So when it is a problem limited to selection only, then we treat it as a problem on combination. Very simple concept it is. I'll directly tell you through the formula set. For example, let's say, again, I'll talk about this particular scenario only. Let's say I have 3 friends, right? Yash, Pratik, and Deepak. So out of these 3 friends, let's say I'm choosing 2 friends. Now the concern is not arrangement. I am not bothered or concerned about arrangement of these 2 persons. I am simply concerned about the selection only. So I'm going for a party and I have 2 tickets, or I'm going for a movie, I have 2 tickets. So out of these 3 friends, how many ways can I choose 2 persons? That can be done in 3C2 ways. So in permutation, we were selecting and then arranging, but here in combination, we are simply selecting it. So if it is a problem of permutation, that means 2 people are to be selected and then arranged, then I'll select them and then arrange them. And that is equal to 3P2 only. So I hope you're able to make some sense out of it. What is that sense I'm talking about? That NPR is always, NPR is equal to NCR into R factorial. What does it mean? Every problem on permutation is a problem on combination first and then arrangement. When you first select and then arrange, this is permutation. So from the formula of permutation, I think I can create a formula on combination as well. So I hope you're realizing we have reached to a conclusion that NCR is NPR divided by R factorial. And we know what is NPR. So if I divide NPR by R factorial, I'll get the formula for NCR. Did you get this particular result as we have already discussed? So remember this. Along with this, there is a short technique as well. What is that short technique? If you don't wish to apply the formula like this, the short technique says, let's say I wish to expand 7c2. So the formula says 7 factorial upon 2 factorial into 7 minus 2 factorial, n factorial upon r factorial into n minus r factorial as per the formula. What if I don't want to use the formula? The short technique for the expansion of NCR says that expand this 7 in reverse until 2 terms. That means 7 into 6 divided by expand this 2 till 1, which clearly is going to be 6 by 2, 3, and 7 into 3 is 21. Let me take one more example. Let's say I am willing to write 11C4. What does it mean? 11C4 can be written as expand 11 in reverse for 4 terms. So 11, 10, 9, 8. These are the 4 terms in reverse, 11. And then 4, you take it till 1. So 4 into 3 into 2 into 1. So that's how this is the short method or a shortcut technique through which you can expand NCR. Will you remember that? Now, if you have gotten this, let me move towards the next part. You should remember few facts, few things in mind. One of them is NCR is always a natural number. Why? Because out of n objects, if r objects are to be selected, chosen, r is of course going to be less than n. That's the funda, that's the rule. So if NCR is what I'm dealing with, then NCR is always going to be a natural number. Because the number of ways in which I can select certain objects out of certain objects, it will be a countable number, a cardinal number. So if it is a cardinal number, which means what? It should be a natural number. This is a fact you should remember, because on this fact only, they have created a question once. I'll show you here in this one shot only. Of course, always remember, NC0 will be 0. Sorry, there is a correction here. NCR will be 0 if R is greater than N. So if you are supposed to select 10 objects out of 3 objects, how can you do that? How can you do that? I mean, how can I select 10 objects out of 3 objects? So I hope you're realizing the catch here, that N should always be greater than R, right? Now, the next funda is NC0, NCN is always 1 and NC1 is always N, which means out of N objects, 0 objects can be selected in one ways. What is that one way? You didn't select any object. That is also one way. Let's say I went to a marriage, a party, and I did not eat anything. I had 7 choices, 7 dishes right there in front of me. So out of those 7 dishes, if I didn't eat anything, so in how many ways did I attend that party? One way. I attended it and I did not eat anything. That is also one of the ways of attending the party. So I hope you're understanding in mathematics, NC0, NCN is 1. What is NCN? Out of those 7 dishes, how many ways can I have those all 7 dishes? Only one way. You have all of them. You eat all those 7 dishes, right? So 7C7 or 7C0 will be 1. Are you understanding the logical explanation? Even through formula also you'll get the same value. Don't worry about that. Similarly, remember that NC1 is N. So out of 7 dishes, if I'm supposed to choose only one dish, that can be done in 7C1 ways, that is 7. Either I take the first dish, or second, or third, or fourth, or fifth, or sixth, or seventh. So how many choices do I have? 7 choices. So NC1 will always be N. These results can be brought through formula as well, but these are some very general and simple results which will ask you to remember. Now, NPR is equals to NCR if R is 0 or 1. You look at NPR formula, whenever R was 0 or 1, or whenever R is 0 or 1 in NCR, it gives you the same result, 1. Along with this, there is one more very important conclusion which we'll talk about, which is very much loved by IIT JEE, that NCR is always equal to NCN minus R. Always remember that. Always remember that. What do I mean by that? Here there is no constraint, something like this. You need not use this constraint over here. I'll always say that NCR is always equal to NCN minus R. Let's say I need to evaluate 11C9. So whether you choose 9 objects out of 11 objects or you reject 2 objects out of 11 objects, that will be same. Let's say I have 11 people right there in front of me and I need to form a team of 9 people. So there are 2 ways. I can either choose 9 people out of 11 objects, or I could reject 2 people out of 11 objects so that I can have those remaining 9 people. Are you understanding my fact or the approach? So 11C9 is equal to 11C 11 minus 9, which is 2. So out of 11, either you choose 9 or you choose 2 for rejection. Did you understand my language? Both are going to be same. I hope you'll remember it. So that's the fact that 11 NCR is going to be NC in minus R. What you should very clearly remember is that 11C9 through dash short technique will be tough for expansion. But here, if I use the formula for 11C2, it will be easy because 11C2 can be written as 11 into 10 up till 2 terms in reverse order, and 2 can be 2 into 1. And that's how you can find the value of 11C2, which eventually is 11C9 as well. I hope you're realizing if this number is huge or large, you can take the difference and write that number. Are you understanding the advantage of this particular formula? And through that, there is a catch that yes, if again you're given that NCX is equal to NCY, don't be in a rush to conclude that X and Y are equal. I hope you can see X and Y are not always equal. Did you see that? So two choices are there. Yes, there is a possibility X and Y could be equal, but there is the other possibility as well that X plus Y could be equal to N, as you can see here. Did you get my point? Did you understand my point? I hope it is making a lot of sense here. Similarly, this is what JEE loves asking. JEE is madly in love with this formula. This is something we have discussed in binomial theorem as well. There also, I emphasized that this is something you should learn. We had done a question as well when we were dealing with the coefficients of a binomial expansion. There we have seen a pattern getting created based on this formula. And I will again in this chapter as well, PNC as well, I'll ask you to memorize this formula. Although while dealing with the binomial coefficients, we had discussed some of these properties there as well. But again, if they are there in this particular chapter, we'll revise them and it's an opportunity to revise them. But here, I'm very strongly insisting that do remember this. How I personally remember this is that let's say, what is the case here? N is same, R is consecutive. Let's say I'm asking you to write the value of 6C5 plus let's say 6C4. Now, what you need to understand is what is the case here. The case is pretty simple. Sir, R is consecutive, C, 4 and 5, and N is same. In that case, what you do is you take the bigger R. So, R and R minus 1, which is 1 is greater, R, which is 5. And you take this N increased by 1. So, 6 when increased by 1 gives you what? 6 plus 1. That is nothing but what? 7, C, and 5 and 4, the greater one is 5. So, this is a result which IIT JEE keeps on asking, and they keep using this particular conclusion a lot many times. And I will strongly emphasize that you should take care of this particular conclusion. I hope you will remember it. Along with this, yes, this is something very crucial. NCR is equal to N upon R, N minus 1, CR minus 1. This is also we'll use a lot many times. What does it mean? It means, let's say I have 7C4. So 7C4, as per the need in the question, I may write as 7 upon 4, 7 minus 1, 6, 4 minus 1, 3. That is 6C3. That's exactly what this formula says. If the need arises, I may use my formula of NCR as N by R, N minus 1, C, R minus 1. Will you remember that? I hope there is no confusion on that. Moving ahead. This is the same formula. This is the same formula. If you expand NCR and NCR minus 1, if you simplify that, you'll get this result. This is exactly what we have also discussed while discussing the binomial formula as well. Even these two results we have had a discussion on. I hope you remember. Among all the coefficients NC0, NC1, NC2 up till NCN, we had a discussion which one is going to be the greatest. So yes, if n was even, there will be only one middle term. But if n is odd, there will be two middle terms and those two coefficients will be same. I hope you remember this particular result and you will remember it through this particular discussion as well. Now, this is what we have discussed in binomial theorem in great detail. I have given you a complete explanation behind that. If you are not able to recall it, do watch that part again of the binomial theorem, the coefficients, the greatest coefficient. Even these results in great detail we have discussed and proved there. NC0, NC1, NC2 up till NCN. Through set theory also we have proved this result. Do you remember that? It is always 2 to the power n. Not just that, this is also what we have derived in that session only based on binomial theorem, that if I take all the even coefficients and all the odd coefficients and if I segregate them and if I take the sum of it, it is always half of 2 to the power n. So half of 2 to the power n is 2 to the power n minus 1. I hope you will have these results with you. These are also some additional results which can be proved based on the formulae which we have just discussed or learned. So you can keep them or you can keep proving them based on what we have learned so far. Now, let's take a question, a very simple question, and let's see what do we get as the answer. This question can be categorized as a question of binomial theorem, but this question here can be treated as a question on permutation and combination as well, because we are simply dealing with the combination coefficient C. So how do I do it? Of course, R is given to be less than N. That is what is the requirement. Now, if I simply deal with this question, how do I deal with this question? Let me write this part first. The first part says N plus 1 C R plus 1 whole divided by NCR, right? And it is given as 55 is to 35. All right. What about the second part? The second part, if I were to write, it is given as NCR divided by N minus 1 C R minus 1. I hope I'm writing it correctly. And it is given as 35 is to 21. I hope there is no confusion on it. There is a complete great clarity on it. Now, do you remember a formula we have just discussed in the last slide? Do you remember that NCR can always be written as N by R times N minus 1 C R minus 1? I had given you an example on this as well. So if I could use this particular formula, can I not get the answer in seconds? And if I have given you the hint, if I have told you the approach, if I already started doing it, you can also start doing it. Don't stuck in this, loop that you just watch the videos, keep watching these videos. Along with these videos, once you have learned the theory, once you have understood the concept, try to solve these problems by yourself. That's the challenging part. Watching these videos is not sufficient. If you are feeling that, if you are assuming or believing that watching these one shots will be sufficient for you, no, it is not going to be sufficient. I am putting efforts here. I am doing something. You are simply watching them. So that won't count. After you have watched these one-shot videos, solve previous year's questions. Even during the session only, we are bringing a lot of questions. Solve these questions along with us. And it requires efforts. It requires some efforts. But once you get into that zone, once you get into that flow, you will love doing it. Please understand. You chose IIT JEE because you wanted to do it, because you love solving problems. And if you like solving problems, here is the opportunity. Sometimes, or maybe initially, our body resists. It does not get into that zone. But if you force yourself into that zone, because you have this requirement, right? You chose it. Now complete it, finish it. So start solving questions, start solving problems. Once you even write 1 or 2 steps, you may get into that zone. And once you get into that zone, once you start solving it, once you get into that rhythm, you will find your flow and you will actually enjoy doing it. To get into that zone, watching these one shots alone is not sufficient. Please take care of it. Getting back to the discussion we were having, I hope you can very clearly see N plus 1 C R plus 1. I won't hesitate in writing as N plus 1 by R plus 1 times N C R. And I hope you won't mind me cancelling this by this. And of course, 55 and 35. So 5, 11 and 5, 7. So this is going to be 11 by 7. So from here, I have reached to a conclusion that N plus 1 by R plus 1, we have written as 11 by 7. Do you have any confusions on that? Can I not do the same here? Not even that. Let's say if I'm multiplying both these sides, numerator and denominator by N by R. If I'm multiplying numerator and denominator by N by R. See, N minus 1 C R minus 1 NCR. Do you not think that this expression is nothing but NCR only? This expression is nothing but what? This expression is NCR only. So again, as you all can see very clearly that this NCR gets cancelled by this NCR. So what are we left with? We are left with, of course, here also, what I'll say, 7 into 5 is 35, 7 into 3 is 21. So as we all can see that N by R is nothing but what? It is 5 is to 3. So from here, can I say N as 5K and R as 3K? I hope, because the ratio of N is to R is 5 is to 3. N and R can be treated as 5K and 3K. So if I replace 5K and 3K here, 5K plus 1 into 7 should be equal to 11 into 3K plus 1. Are you getting what I'm doing here? I hope there is no confusion on that. Now, if I move ahead, what conclusion will I get? 7 into 5, 35 plus 7. So 7 into 5 is 35K plus 7. Are you getting this part here, students? And 11 into 3, 33K plus 33. So this is 33K plus 33. So 35K plus 7 and 33K plus 33. right? Now, what I do next is, I hope you have the result here. 35 minus 33, that is 2k, and 33 minus 7, this should be 26, I believe. Yes. So we have gotten the value of k as 13. Let me just cross check it once again. 33 minus 7, 3 and 4, that is 26. This is 2, so 26 by 2 is 13. So k we have received as 13. So I think I'll have n as 13 into 5. 13 into 5 is, I think, 65, half of 130. Yes. And 13 into 3, which is 39. So r is going to be 39. What were we asked? We were asked 2n plus 5r. I hope I'm not committing any error, because to me, the value looks amazingly huge. I hope I've not made any error or mistake here. Let me just cross-check this part again, because 2n plus 5r will be huge and this is not matching. This is clearly not matching with the correct option here. Let me cross-check this part again. What did we begin with? N plus 1 CR plus 1, NCR. So I wrote it as n plus 1, r plus 1, NCR got cancelled. 55, 35. It is 11 and 7. I hope you are going great. So n plus 1 upon r plus 1 is 11 and 7. 7 into n plus 1, 11 into r plus 1. Okay, let's talk about this part. NCR, n minus 1, CR minus 1. So n minus 1, CR minus 1, I multiplied n by r in the numerator and denominator. So the numerator was NCR into n by r. Denominator was n by r into n minus 1, CR minus 1, which I can write as NCR. NCR is cancelled. So 35 by 21, 7 into 5 is 35, 7 into 3 is 21. And 5 into 11, 5 into 7. Yes, that is also fine. So n by r is 5 by 3. So n is 5k, r is 3k. So if n is 5k and r is 3k, 7 into 5k plus 1, 11 into 3k plus 1. So this is 35k plus 7. Yes. And this is 33k plus 11. Yes, I think I'm making an error. It is not 33. Yes, I'm really sorry. 11 into 1 is what I need to do. This is what happens. Usually when I flip from this slide to this slide, I usually, commit mistake here. So that is what you need to be aware of. Even while doing the calculation, take care of the numbers. Let's say you're flipping the page, you're doing the calculation on the next page. So take care of the data. Like the way I mistakenly took this one as 3 because of this 3. And that is a very normal error, very silly mistake. Anyone can commit. So take care of such mistakes, because it will cost you heavily. You were conceptually right. You were absolutely right. And this silly mistake that you took this one as 3 because of this 3 made you do all this thing. And what if it was a input type question? You would not have these options. You will simply calculate and mark the answer. And that's where you will get the negative marks, get the wrong marks. I hope you're understanding why. So let me get back to this part. This is not 33. 11 into 1 is 11. So there is a correction. It should be 11. So the correction will give me 35 minus 33 should be 2k, and 11 minus 7 should be 4. So k should be 2. Once you have taken k as 2, I think the correction will be n will be 10, and r will be, this was 10 and it should be 6. So 10 and 6. So 2n means 20, and 5r, that is 30. So 20 plus 30 should be 50, and that is given in the option A. Did you get this result? Are you understanding? If you know the basics, if you know the formulae, you can solve questions with simple calculation involved. I hope you knew it. Now, moving ahead towards the next part of the discussion we are having. Now we are talking about restricted combination. Again, I'll say, instead of discussing like this, I'll take some examples and make you understand it through that. For example, let me take certain examples instead of giving you all these formulae. Please don't try to learn these. Again, this is something which I'll try and make you understand through some simple examples. Let me take an example here. Let's say I have 16 players right there in front of me. All what we have skipped so far in terms of learning those formulae, I'll give you an example and make you understand it more logically. That logical approach you should remember. So let's say I have 16 players right there in front of me, and I am the captain of the team. And I need to form a team of 11 players, a cricket team of 11 players. So I need to decide that playing 11, right? So since I'm the captain, I have already chosen myself. So do you really think that I need to form a team of 11 players? No. Out of 16 players, I need to form a team of 11 players. But the problem is, I being the captain is already chosen. So if I am already chosen, do you not think that now I have left with 15 choices, and out of those 15 choices, I need to make 10 selections. So the answer will not be 16C11, the answer will be 15C10, because one person out of these 16 players is already chosen. Did you get that? So that kind of scenarios or constraints or restrictions can be imposed, and there you need to take care of this. Similarly, let's say there could be some other scenario. Let me just take or understand these scenarios. This is one of those scenarios. For example, here, let's say you have certain number of objects right there in front of you. Let's say, let's take any scenario. Let's say you have 4 dishes right there in front of you. Dish number 1, dish number 2, dish number 3, and dish number 4. You are in a party and you have these 4 dishes right there in front of you. And you want to feed yourself. So in how many ways can you feed yourself? So the logical approach will be, sir, for dish 1, I have 2 choices. Either I will eat it or I won't eat it. So the same number of choices I have for dish 2, the same number of choices I have for dish 3, and the same number of choices I have for dish 4. I hope you remember this is the formula we have already discussed. 2 choices for dish 1 and 2 choices for dish 2 and 2 choices for dish 3 and 2 choices for dish 4. Which means in that party I can feed myself in 2 to the power 4 ways, which is wrong. Why? The catch here is that if I don't eat any dish, so I have chosen, let's say, no from here, no from here, no from here, and no from here. That is one way in which I am not eating any dish at all. So if I'm not eating any dish at all, so out of these 2 to the power 4, 16 ways, there is this one way also in which I did not eat any dish at all. So if I'm asking about feeding myself, so I should eat at least one dish. So in these 2 to the power 4 minus 1, which are 15 ways, in those 15 ways, I'm eating either exactly one dish or exactly 2 dishes or exactly 3 dishes or all 4 dishes. Now exactly one dish, I could eat either D1 or D2 or D3 or D4. When I talk about eating exactly 2 dishes, I could eat either D1, D2 or D1, D3 or D1, D4 or D2, D3 or D2, D4 or D3, D4. When I talk about having exactly 3 dishes, in that case, I may have D1, D2, D3 or D1, D2, D4 or D2, D3, D4 or something like that. So I hope you're understanding these are all possible cases which I need not calculate manually because we have these formulae. We know the basic principle of counting and and or, multiplication and addition. If you know that, you can apply them. So I'm constantly repeating, not many formulae are supposed to be learnt. Just understand the logic. Just remember the logic. This is again the same case. For example, again, let's say here, I'll try and tell you this formula through an example only. Let's say I have certain number of objects. Out of certain objects are alike and other are not alike. I'll take an example here as well. Let's say I go to a fruit shop. So in that fruit shop, there are some apples, there are some oranges, and there are some bananas, right? Please understand now. What we are assuming here is that all the apples are identical. You cannot distinguish them. You cannot differentiate them. They all look similar. All the bananas are same, all the oranges are same. So there are infinite apples, there are a lot of bananas, oranges, and apples are there. So let's call them infinite. So I have a lot of choices. But what I have is that I need to bring 4 apples. Let's say at home I want to have 4 apples, 3 oranges, and 5 bananas. Did you get that part? So in how many ways can I choose that? In how many ways can I have that? So out of these available apples, any number of 4 apples you choose, I hope you're realizing you cannot segregate any choice. Are you understanding my point? So whichever 4 apple you're choosing the same apples because you're not able to segregate this set of 4 apples from the other set of 4 apples because they look same, they look similar. So when objects become identical, you need to keep this thing in mind that they are counted same, they are not different. Are you understanding the logic here? Let's be more logical. So my point is very simple. Let's say there were certain number of apples available, there were certain number of oranges available, there were certain number of bananas available. I'll say the number of ways in which I can have 4 apples will be 1 only. Because no matter how many times you pick any 4 apple, those 4 apple look same. So you would not say or count it as a different set of 4 apples. Are you understanding my point? Because they look same. These are the same 4 apples which you chose previously. Although they could be different. Of course, I totally get your point. But how will you distinguish? How will you identify it? Because they are appearing same. And you cannot say that these are 4 different apples. If they are not looking different, you cannot claim that. Are you understanding my language? Are you understanding the problem here? So this will be only one case. So that's what I'm trying to make you understand. that if you take care of the language here in this question, you will be more convenient and comfortably will be doing the questions. Let's take one more example. Let's say I go to a party. We all love eating. It's the season of winter. We all enjoy, eating or having good food. Since you're preparing for the exam, avoid eating a lot. Have a proper diet. Always have a balanced diet. So what I'm saying is, let's say I go to a party. I go to again a function, a marriage, or a, let's say, event. In that event, let's say I have certain options. For example, I have 4 different varieties of chapatis. Different varieties of chapati. So let's say first category of chapati, second category of chapati, third category of chapati, fourth category of chapati. So these are 4 different kinds of chapatis are there. For example, this is a chapati, this is a paratha, this is something else, this is a bread, and this is some other thing. So 4 different types of chapatis are there. Similarly, let's say there are 3 different types of vegetables are there. Vegetable 1, vegetable 2, vegetable 3. And similarly, there are 5 different types of sweets are there. So sweet 1, sweet 2, sweet 3, sweet 4, sweet 5. I hope you're understanding it. Now, again, if my question is that in how many ways can I feed myself? So what will you say? You will again come up with the same response. Which response? Sir, in how many ways can I have a chapati? Because in that thali, the Indian thali which I'm talking about, there is a rule that I should have at least 1 chapati. So there should be a type of chapati, there should be a type of vegetable, and there should be a sweet. So this is the constraint. If you're having a chapati and a vegetable and a sweet, then you'll be calling yourself to be eating something. So if I go to the chapatis and ask them in how many ways can I eat you? So first chapati has 2 choices, second has 2 choices, third has 2 choices, 4 has 2 choices. So there are 2 to the power 4 choices I have to have chapatis. But again, do you remember there is a catch? There is one possibility in which I'm not having any chapati at all. So to have chapatis, at least 1 chapati, I should have 2 to the power 4 minus 1 ways. And in how many ways can I have vegetables? 2 choices, 2 choices, and 2 choices, which means 2 into 2 into 2, which is 2 cube. 8 ways I can have vegetables. But out of those 8 cases, there is one case in which I'm not having any vegetable at all. So can you eat chapati alone without vegetable? No, you cannot. So out of these 8 cases, I'll be excluding that one case in which I'm not having any vegetable at all. Of course, your meal is not complete or is not considered to be completed once you have not eaten the sweets. That's a rule, right? So that thumb rule also needs to be followed. So you can have any number of sweets. You can have first sweet or second or third or 4 or 5 or all or any 2 or any 3 or any 4 or all 5. But none is not there. You should have at least one. So again, 2 choices and 2 and 2 and 2 and 2. So I have total 2 to the power 5 choices. But out of these 32 choices, there is one choice in which I have not selected any. No, 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 no. So that one case should be discarded. So if I'm discarding that one case, these are the ways in which I can feed myself in a party having these options. Are you understanding it? So if you are able to crack a certain scenario logically, you need not learn a formula. And that's exactly what I'm saying here. So I hope you will have this thing in your mind. You will remember these scenarios. And if you could remember, let's understand this particular case or a problem and let's take more clarity. Let's get more clarity on this. What does the question say? The question says that from a group of 7 batsmen and 6 bowlers, 10 players are to be for a team. Okay, so let me write this data here. How many batsmen do I have? So I have 7 batsmen. I have 6 bowlers. Okay, and I need to choose 10 players. All right, so I need to make a team of 10 players. So we have the data. Now it has a constraint. What is that constraint? That it should include at least, include at least 4 batsmen and at least 4 bowlers. So the team must have at least 4 batsmen and 4 bowlers. Okay. There is one more condition. One batsman and one bowler. One batsman and one bowler who are captain and vice captain respectively should be included. So these 2 players are already included. I hope you remember the case. We had a discussion 16 players, 11 players. Do you remember that case? The same kind of question it is, right? Or the basic principle of counting will be applied here. How? We'll talk about that. Now, let's start solving this particular question. What is the problem here? I need to make a team of 10 players. So I will remember that I need to form a team of 10 players, right? In which I should have at least 4 batsmen and at least 4 bowlers. Please understand, can I not say out of these 10 players, I have already selected one batsman who is the captain, and I have already selected one batsman and one bowler who is the vice captain. So do you not think that when they were saying that you should have at least 4 and at least 4 batsmen and bowler respectively, then now your condition should be at least 3 and at least 3, at least 3 batsmen and at least 3 bowler, because one batsman and one bowler is bound to come as a captain and as a vice captain. I hope you remember, they were telling us that the one batsman and one bowler who are captain and vice captain must be there in the team. They should be included. So if I have already included one captain and vice captain, in which I was trying to form a team of 10 players, do you not think that now my problem is boiled down to forming a team of 8 players? And in that configuration of 8 players, there should be 3 batsmen minimum and 3 bowlers minimum. What about the rest? Rest could be anyone, rest could be anything. So I hope you have understood the problem. So now I'll divide it into different scenarios. What are the different scenarios? See, the different scenarios could be, I can have 3 batsmen and 5 bowler. Are you understanding it? 3 batsmen and 5 bowlers. Why? I hope you are realizing I need 8 players. Out of 10, 2 are already chosen. Definitely chosen. So I need to form a team of 8 players in which minimum 3 batsmen and 3 bowler are to be chosen. So let's say I have chosen 3 batsmen, but I'm choosing 5 bowlers to make it 8. Do I have the liberty to choose 5? Yes, because I have 6 bowlers available with me. Right. Second case, or means addition. Or means what? Or I'll choose 4 batsmen and 4 bowlers, because I need to form a team of 8 because 2 are already chosen. Or can I go further? And take 5 batsmen and 3 bowlers? And that's the minimum requirement. I cannot go beyond it. Because if I say that 6 batsmen and 2 bowlers, no, that is not true, because I need to have minimum 4 bowlers, out of which one is the vice captain. So 3 bowlers are minimum supposed to be there. So these are the 3 cases. Now, how many choices do I have initially? Initially, I had 7 batsmen and 6 bowlers. But out of these 7 batsmen and 6 bowlers, 1 batsman and 1 bowler, which are captain and vice captain, are already chosen. So out of 7 batsmen, I am left with 6 batsmen, and out of 6 bowlers, I am now left with 5 bowlers. Are you getting this condition here? Because 1 captain and vice captain, which are batsman and bowler respectively, are already selected. So I have 6 batsmen and 5 bowler available with me. 6 batsmen and 5 bowler available with me. So how many choices? I have 6 batsmen and 5 bowler available with me. I hope you are remembering and understanding this part very clearly. No problem, no confusion at all. Now, moving ahead. Out of 6 batsmen, 3 batsmen can be chosen in 6 3 ways. Classical problem on combination. And means multiplication. 5 bowler, out of 5 bowler can be chosen in 5C5. That is only one way. Or 4 batsmen. So out of 6, 4 batsmen can be chosen in 6C4 ways. And 4 bowlers out of 5 bowlers can be chosen in 5C4 ways. Or, I hope you're understanding how am I using the conjunctions and or. And means multiplication, or means addition. Or, I need to make a selection of 5 batsmen out of 6 batsmen. That can be done in 6C5, and 3 bowlers out of 5 bowlers can be done in 5C3 ways. From here onward, I don't think I need to solve it. Now you all are intelligent enough to solve and expand it. Do you remember the short technique we have discussed to expand this particular NCR formula through that short method? My motive was to make you understand its logical approach. Were you able to get that? The logical part, how should you deal with? If you have understood that part, I think marking the correct option will be easier. First of all, bringing clarity about the question, the data, the logical question, structuring the data, understanding the problem, comprehending the data. So we interpreted the question well, and once you have gotten the data well, your brain was intelligent enough to come up with an approach, with a logical idea that how should you solve this particular question. As we keep on mentioning this thing, that invest a lot of time in understanding their question, because the more you understand the question, the better you understand the question, the higher are the chances that you'll be able to solve it. Once you understand the problem, half of the problem is solved. So invest a lot of time in understanding the problem. This again, I will try to explain with an example here. Let's say I have a number, any number we can take. Let's say I'm taking a number which I'm writing in its prime factorized form. What do I mean by that? Let's say I'm writing it as 2 cube, 3 square and 5 to the power 1. So this is the number. Of course, this number is going to be 8 into 9 into 5. I hope you're understanding it. But that number I am writing in its prime factorized form. What is prime factorized? So let's say the number was 8. 8 into 5 is 40. 40 into 9 is 360. So basically, originally, the number was 360. So what I have done is, I have divided 360 into its prime factorized form, product of its prime factors, powers of its prime factors. So 360 is basically 36 into 10. And 36 is 9 into 4. And 10 is 2 into 5. And that's how I have written it as 2 cube into 3 square into 5 to the power 1. Now, there are also some questions which are formed using permutation and combination based on this particular concept. Now, what is the concept? Let's learn that. Now, the first category of question which arises is that, let's say, if I'm asking you the first question here, the total number of divisors of n including 1 and the number n. So here, let's say, if I were to ask you how many numbers are there which can divide 360, will you start counting 1, 2, 3, 4 like that only? Will you start counting all the numbers which are dividing 360? No. Do this prime factorization of 360 first. And do you not realize all the possible combinations of these prime factors will give you the factors of 360? I am trying to make you understand a very simple thing. Let's take another example. Let's say there is a number 24. Now, what is 24? The factors of 24 are 1, 2, 3, 4, 6, 8, 12. I hope I'm going great. And after 12, I think it should be 24. Now, let's look at these numbers. Look at these numbers. What is 1? 1 is 1. What is 2? 2 is 2 to the power 1. What is 3? It is 3 to the power 1. What is 4? It is 2 square. What is 6? It is 2 into 3. What is 8? It is 2 cube. What is 12? It is 2 square into, I think, 3. Right? 4 into 3 basically. 24 is basically 4 into 6, or rather 8 into 3. So this is 2 cube into 3 to the power 1. Now, are you not noticing 1 is 2 to the power 0 into 3 to the power 1? 2 is 2 to the power 1 into 3 to the power 0. 3 is 2 to the power 0 into 3 to the power 1. 4 is 2 square into 3 to the power 0. 6 is this. 8 is 2 cube into 3 to the power 0. Sir, why are you writing it like this? I am trying to make you understand something very simple and straightforward, that 24, if I could write it as 8 into 3, which is 2 cube into 3 to the power 1. So 2 cube had 4 choices. Which 4 choices, students? 2 cube had 4 choices, either to be 2 to the power 0, or 2 to the power 1, or 2 to the power 2, or 2 cube. And what about 3? 3 had 2 choices, to be either 2 to the power 0 or 3 to the power 1. So now whichever combination I choose, let's say I have chosen 2 to the power 0 and 3 to the power 0, which made it 1, and 1 could divide 24. Let's say I'm choosing 2 to the power 1 and 3 to the power 1, which is 6, and 6 was able to divide 24. So if I look at 2 cube, it had 4 choices. If I look at 3 to the power 1, it had 2 choices. So 4 into 2 gave me 8 choices. So total 8 numbers were there which could divide 24 perfectly. Can you not see it right there? 1, 2, 3, 4, 5, 6, 7, 8. Are you able to deduce a logic or a formula here? What is the formula? Number of ways in 2 cube can be chosen. It will be, sir, either 2 to the power 0 or 1 or 2 or 3. And number of ways 3 can be chosen, could be 3 to the power 0 or 1 or 2. And number of ways 5 can be chosen will be either 5 to the power 0 or 5 to the power 1. So in how many ways can I have 2? I can have 2 in 4 ways. And I can have 3 in 3 ways. I can have 5 in 2 ways. So 4 into 3, 12 into 2, 24. So there are 24 factors or divisors of 360. So you need not actually calculate them. You could directly state that yes, there will be 24 numbers which will divide 360, including 1 and 360 itself. Did you understand the whole approach? If I were to give you a formula, the formula is pretty simple. Increase this 3 by 1, increase this 2 by 1, increase this 1 by 1, and multiply them. 4 into 3 into 2. That's 24. So formula is also there for you. You can remember or learn that formula, but along with that formula, did you understand that logical approach? There are some more formulae yet to come. I'll explain all those formulae, but not in this detail. But of course, the first formula has made a complete or great sense here, right? So let's talk about the next formula. The total number of divisors excluding 1 in the number. I hope you're realizing now that if I don't have 1 in the number, then out of total divisors, I need to subtract 2. Similarly, if I ask you the total number, that is something very simple. You need not even discuss this. This is something more important. Sum of all divisors. What does that mean? Sum of all divisors. That's a very important and a very crucial formula. Let me take this example of 360 again. I hope you remember we were able to write 360 as I think 2 cube and 3 square and 3 square I think, and 5 to the power 1. Let me cross check it again because 2 cube is 8 into 5, 40, 40 into 9 is 360, yes. Now, if I am willing to write all the factors of 360, so with the 2, I can have 2 to the power 0 or 2 to the power 1 or 2 to the power 2 or 2 to the power 3. And with the 3, I can have 3 to the power 0 or 3 to the power 1 or 3 to the power 2. And with the 5, I can have 5 to the power 0 or 5 to the power 1. I repeat, with 2 we have these 4 choices, with 3 we have these 3 choices, and with 5 we have these 2 choices. Now, I hope you are realizing these 4 into these 3 into these 2, 24 choices I'll be getting. How? Let's say one of the cases could be 2 to the power 0 going to 3 to the power 1 and going to 5 to the power 1. So it will give you 1 into 3 into 5, which is 15, and 15 can divide 360. So this is how I'll have those 24 numbers, which will be the divisors of 360. And I want the sum of those numbers. So can I not have the sum of those numbers in this manner? Why? Because I can add these numbers here like this. You can add them as a sum of GP, or you can simply add them. So I'll have this 1 plus 2 plus 4 plus 8 into, it is going to be 1 plus 3 plus 9. And from here, I'll have 1 plus 5. Although by using the formula of sum of n terms of a GP, you can create it, but here, instead of doing that, I think this was more convenient and easy and visible. I'll simply calculate it and multiply it and get the answer. And that value will be nothing but what? Sum of all the divisors or divisors, whatever you pronounce it, of 360. So all the factors of 360, if you add them up, this will be that only. Why? Because 2 to the power 0 into 3 to the power 0 into 5 to the power 0 will be first factor. 2 to the power 0 into 3 to the power 1 into 5 to the power 0 will be second factor. So such all possible combinations will be the all total divisors. And I hope there is a standard method for it. So instead of finding all the divisors, this is also a method through which you can do it. Did you understand this part? And that's exactly we are given as a formula here. So I hope you are making a complete sense out of it through the logical approach as well, which I have tried giving here through this example. Now, sum of proper divisors, which means excluding one, an expression itself, which we have already discussed, n plus 1. So these are all formulae which we have already discussed logically as well. You need not worry about it. Now the next case. Let's say it is asking you the number of odd divisors of n. I'll take this example again. We had this number 360, which we have written as 2 cube, 3 square, and 5 to the power 1. So when do you have a number to be odd? Sir, a number becomes odd if it contains a 2. If you multiply any number by 2, it becomes even. I hope I'm saying it correctly. I'll re-repeat it. Whatever I have said, just forget that. I'll re-repeat it. A number becomes even if it contains 2, which means if you multiply a number by 2, it becomes even. So if I want to look at all the divisors of 360, all the factors of 360, which are dividing 360, but they should not be even, they should be odd. So when can I ensure that they all are odd? I can ensure that all of them will be odd if there is no 2 in them. So let's not include 2. So in how many ways can I have 2? There were 4 ways. 2 to the power 0, 2 to the power 1, 2 to the power 2, or 2 to the power 3. So if I don't include them, basically I'm including 2 to the power 0. 2 to the power 0 means I'm not including 2. So there is one way of having 2, which is you don't have it. So in one way I can have 2. In how many ways can I have 3? 3 can be taken in 3 ways. 3 to the power 0, 3 to the power 1, 3 to the power 2. So there are 3 ways of having 2. What about the number of ways of having 5? There are 2 ways, 5 to the power 0 or 5 to the power 1. So there are 2 ways of having 5. So I got 6 factors or divisors which are odd, which can divide 360. I hope you understood it. What if I am asking you to have even divisors? These are 6 odd factors of 360. So one of the ways is, sir, factors could be either even or odd. So out of total number of factors of 360, which were 24, if I remove these 6 factor, which is 18, I'll be left with even number of factors. First approach. Second approach, do you not think now instead of excluding 2, let us mandatorily include 2? Then how many ways can I have that? Sir, now if I am willing to include 2, these are the 3 cases. So if I want to keep the factor even, I need to have a 2, and 2 can be taken in 3 ways. What about having 3? 3 can also be taken in 3 ways. What about having 5? 5 can be taken in 2 ways. So 3 into 3, 9, 9 into 2, 18. So there are 18 even factors of 360. Did you understand this part as well? Are you able to get or make some sense out of it? The same formula they have given you over here. So I think you need not worry about these results. Right. Now let us move towards the next set of rule or formula, where we'll talk about division of objects into groups. So this time we'll discuss division and then we'll talk about distribution. Let us take an example and understand it more clearly. For example, let's say I have 20 friends, right? 20 friends with me. And I intend to form two groups. Let's say one group is of 12 people and other group of 8 people. Now how simple it is. Why? Because out of these 20 people, let's first select 12 people. I hope you're realizing. Let's say out of these 20 people, if I'm selecting the 12 people, so out of these 20, 12 persons can be selected in 20C 12 ways. And then what am I left with? 8 people. So out of those 8 people, 8 people can be selected in 8C 8 ways. Are you understanding my statement? Which is going to be 1 only. So once you have selected 12 persons, you are left with 8 persons, which you need not select because you are left with 8. They are already selected. Did you get that part? Now, if I wish to write 20C12, how will I expand it? I'll write it as 20 factorial upon r factorial into n minus r factorial. Are you understanding or seeing a pattern here? 20 was the size of the group, the entire lot. And then I wanted to divide them into two groups of 12 and 8. Did you get that part? If still you are confused, I'll take one more example. Let's, instead of a group of 12 and 8, let's say I'm making a group of 7, the second group of, let's say, 6. So this is, let's say instead of 6, let's make a group of 5. And the third group of 8 people. So I want to divide these 20 people into a group of 7, 5 and 8. 3 groups I want to make. How will I do it? Again, the process remains same. Why? Let's form a group of 7 first. So out of 20, 7 can be chosen in 20C 7 ways. And then after choosing these 7, how many am I left with? So 20C 7. I hope you are very clearly seeing I'm left with 13. So out of 13, let's choose 5 people for the second group. Now, how many am I left with? I'm left with 8 people. So out of those remaining 8, 8 can be chosen in 8C 8 ways, which is only one way because you're left with 8. Third group is already formed. Now, if I were to expand it, what will I get as the expansion? 20C7 is going to be 20 factorial upon 7 factorial into 13 factorial. 13C5 is going to be 13 factorial into upon 5 factorial into 8 factorial. I hope there is no confusion on it. And when you talk about 8C8, which is 8 factorial upon 8 into 0 factorial, which is going to be 1 only. So I'm not writing that part. I'm writing it as 1 only. Did you get that part? If I simplify this result, if I simplify this result, 13 factorial and 13 factorial are cancelled. Do you not think the conclusion which I'm getting is 20 factorial upon 7 factorial into 5 factorial into 8 factorial? Are you not noticing a certain pattern here? I had a group of 20 people, right? So out of these 20 people, I wanted to divide them into a group of 7, 5 and 8. Do you not think that we have developed a formula here? And that's exactly as a formula I'm willing to discuss, that if I have a certain group of, let's say, m plus n people, out of which I want to form a group of m persons and another group of n persons, the idea is very simple. In the numerator, write m plus n factorial and then divide denominator by m factorial into n factorial. That will be the division. So did you understand this whole formula? Is this pattern making some sense out of it? I hope you're able to understand. 20 friends, 20 factorial. 3 groups, 7 factorial, 5 factorial, 8 factorial. Now let's create one more case. Which case? Let's say, of course, we have understood how to divide them. So this was division, that 20 people can be divided into a group of 8, 7 and 5 in these 3 ways. But this time I'm labeling these groups. So these times the groups are group 1, group 2 and group 3. So previously that, let's say that lot of 8 people, let's say I'm calling that one lot of 8 people as A, the second lot of 7 people as B and that lot of remaining 5 people as C. So those A, B, C could be arranged in these 3 groups in 3 factorial ways. Do you not think? A, B, C, A, C, B, then B, C, A, B, A, C, then C, A, B, C, B, A. So there are 3 factorial 6 ways. So my point here is, let's say if the groups are labeled. Previously, I haven't labeled the groups. Previously, I did not label the groups. The question was of division only. The problem was of division only. So when it was restricted to division, division means out of 20 people, create 3 groups. One should contain 8 people, other should contain 7 people, the third should contain the remaining 5 people. The idea is very simple, 20 factorial upon 8, 7, 5 factorials individual. But if I label these 3 groups, so I am dividing them into 3 groups, group 1, group 2, group 3. So now how will I do it? So sir, any group, so name can be any, so G1, G2, G3 are the 3 names of the groups. Now this time, after dividing them, should I not distribute them? So when distribution comes into picture, these 3 groups into these 3 bunch of people can be distributed into 3 groups in 3 factorial ways. So are you realizing and understanding? This is division and then this is distribution. Same as combination and permutation. Permutation is selection, then arrangement. So now division, if it was all about combination, distribution becomes a problem on permutation. Are you understanding the difference? Are you able to make some sense out of it? Why am I multiplying by 3 factorial? Now, let me get back to this part here. This is exactly what we are doing. Let's say m plus n people are there and I'm willing to divide them into 2 groups and I'm labeling those groups. So I'm defining those 2 groups distinctly. So once you have defined these 2 groups, right? Then of course I'll say that that division into m and n objects will be m plus n factorial upon m factorial into n factorial. But since 2 groups are distinctly defined, then I should multiply it by 2 factorial as well. Are you able to digest this part here very clearly? Let me take some more examples. For example, again here, let's say I have 3 persons, M and P, M plus N plus P. That is a group of M plus N plus P people, out of which I want to form a group of M people, another group of N people, and a third group of remaining P people. So how will I do it? As we have already discussed, M plus N plus P factorial in the numerator divided by M factorial, N factorial, and P factorial. What if I label these 3 groups as G1, G2 and G3? In that case, I hope you won't hesitate in multiplying it by 3 factorial. Are you understanding the result? So this is division into 3 factorial will become distribution. Are you able to understand the difference over here? Well, sir, if it is so easy, then what is the catch? There should be a catch. So what is that catch? Let us talk about that catch. The problem is, let's say if this is the generalization, if the group contains unequal number of people. But what if number of people is equal? What do I mean by that? Let me talk about that here. Let's say there are 30 persons. Let's say there are 30 objects. I want to make 4 groups. Out of those 4 groups, let's call 5 groups. Out of those 5 groups, let's say there are 2 groups which contain 5 objects each. So out of 5 and 5, 10 are distributed. Now how many am I left with? I'm still left with 20 objects. So those 20, let's say I'm distributing as, let's say 7, which is basically 14, and then 6. I hope it is understandable that these 30 objects I'm willing to distribute like this. First group contains 5, second group also contains 5, third 7, fourth 7, and fifth 6. So 14 plus 6, 20 plus 10 is 30. I hope you're getting it. So idea is simple. What some of you might say that, sir, the answer should be 30 factorial divided by first group size 5 factorial, second group size 7 factorial, third group size 7, fourth group size 7 factorial, and the fifth group size is 6 factorial. That should be your answer. But are you not realizing there is a problem? let's say 5 distinct people go to this group and the other 5 people distinct go to this group, or those 5 go to this group and those 5 go to this group, that is counted additionally. That should not have been counted by us because it is simply division. So if A, B, C, D, E, these are the 5%, they are kept either here or here. I am dividing those 5 in that group of 5 only. So whether you post them here or here, since the groups are not labeled distinctly, does it make any sense that I am counting those extra cases additionally, which are not there at all? I hope you remember the example of mathematics where M, A, and T were appearing twice, and those were getting added or counted doubled. And that's where I had to divide them. So here also I need to remove it. So here, if some cases or some groups are repeated, for example, our group size of 5 is repeated twice. So I need to divide this whole result by 2 factorial. And our group size of 7 is also repeated twice. So I need to divide this whole result by 2 factorial. So the number of times a group size, the same group size is getting repeated, then you divide it by that same number's factorial. The number of times it is getting repeated to avoid that extra counting. And of course, A upon B whole upon C should be A upon BC. So instead of writing this 2 factorial and 2 factorial here, I can write it here as 2 factorial into 2 factorial. So this is all our division, but that extra counting needs to be removed, and that is being done with this 2 factorial and 2 factorial. The size 5 has appeared twice, and this size 7 has also appeared twice, and that's why we are doing it. So are you understanding this division? The same phenomena I'll try and explain you here. That here, I hope you can see that m plus n objects were there. I repeat, m plus n objects there, right? The number of ways in which mn distinct objects. Okay, so this time mn distinct objects are there, and I'm creating n groups of n objects. So let's say m into n objects are there total. These are the total objects. I created first group of size n, second group of size n, third group of size n. So such m groups of the same identical size of n I am creating here. So I hope the numerator will have total number of people, which is mn factorial, total number of people divided by n factorial into n factorial into n factorial into n factorial m times, which will give you n factorial raised to the power m. But again, this size, the same size is repeated m number of times. So I need to divide this result by m factorial. So there this m factorial comes. Are you able to understand that when the group size is identical, then in the division, you should take care of this factor as well? Did you get that part? With that, there comes one more catch. Which catch? Sir, if the order of group is important, again, if I label the groups G1, G2, G3, in that case, do you not think that I need to multiply it by m factorial so that the number of arrangements are also introduced? So far, previously we were dividing. Now it is distribution. I'll try and make you understand with this example over here. Let's say there were how many people, how many groups? 5. So 30 people are divided into 5 groups like this of sizes 5, 5, 7, 7 and 6, where this size was repeated twice, this size was repeated twice, so I divided them by 2 factorial and 2 factorial. But let's say the order matters. Let's say the first group is needed to be sent to Chennai, second is Bangalore, third is Agra, second is Lucknow, and fifth is Bhopal. In that case, the order is important. So if order comes into picture, there you introduce permutation. So these 5 groups can be arranged in how many ways? 5 factorial ways. So there I'll introduce this arrangement 5 factorial, because now order has come into picture. Did you understand this whole part very clearly? Shall I explain this part again? Have you gotten complete clarity on division and distribution? And if you have gotten this part, let us move towards the next part where this is the scenario, this is an example which we have already discussed, so I don't think that we need to take it. Let us now understand it through a question. Sir, how does this question looks like a question on division and distribution? Trust me, it is. And it is an amazing question asked by JEE in 2024. By looking at it, some of you might feel, sir, it is not doable. We cannot do this question, and it is something really huge. You cannot predict or say anything about the number without calculating them. I get it totally. Do you remember 2 things we have discussed in this one shot only? First thing, that previously we have discussed that NCR will be a natural number because it gives you the number of ways in which R objects can be selected out of N objects. Second phenomena. Do you remember the concept of division and distribution? If you have remembered these two concepts, let me bring those two concepts here in this question. How? That's the catch. Let's look at that. Here, 4 factorial factorial divided by 4 factorial to the power 3 factorial. Okay, okay. Can I rearrange this data as per my requirement or as per my need? Let's try and do that. Here, let's forget alpha for a while, but let's look at what is written in alpha. Let us try to make some sense out of it. So alpha has 4 factorial. As I have already said you or told you in the beginning of this session, that learn these values 1 factorial, 2 factorial, 3 factorial, up till 10 factorial you should be well versed with. You should have these values at your fingertips. If they are there with you at your fingertips, they will actually help you in solving a lot of questions more quickly. How? Let's have a look at that. 4 factorial is 24. So the numerator has 24 factorial when I'm talking about alpha. Numerator has 4 factorial in the denominator. I'll keep that 4 factorial as it is, but this 3 factorial, can I not crack as 6? 3 into 2 is 6, so I'm writing it as 6. Sir, we didn't get your point. Why are you writing it like this? Okay, forget this data. Although this is alpha. We know that this is alpha. Let me write beta as well, then we'll talk about both of them. Beta is 5 factorial factorial. Okay, what is 5 factorial? 4 factorial is 24. So if I multiply 24 with 5, I'll get 5 factorial. I hope you're understanding the motive. So 24 into 5 is 120. So the numerator has 120 factorial and the denominator has 5 factorial to the power 24, which is 5 factorial to the power 24. Now, by looking at this, you may be realizing something which we have just discussed when we had a discussion on division and distribution. Even if you are not getting it, let me take you through something else. What I'm trying to make you understand is, forget this alpha. Let me write a number here, 24 factorial upon 4, what's wrong with this, 4 factorial raised to the power 6. Now, let's say, I don't know why, you will understand it in the next step only. I can do it through my intuition, which you will also develop by solving a lot of problems. But here, I am willing to multiply and divide it by 6 factorial. I don't know why, but I am willing to do it. I hope I'm not making any changes to the alpha. It is still alpha. Why am I calling it to be alpha? And why am I still calling it to be alpha? Because here, 24 upon 4 factorial to the power 6 was alpha. And I have multiplied and divided by 6 factorial. That does not make any changes here. But why are we doing it? Now I am asking you to look at this part. Can you help me with 4 into 6? Sir, 4 into 6 is 24. And that's the part where you should put your focus upon. What I'm saying here is, let's say I have 24 objects. Let's say I have 24 objects. And I am dividing those 24 objects into 6 groups of 4, 4, 4 each. Into 6 groups of 4, 4, 4 each. And how many ways can I do that? Well, formula for that will be 24 factorial divided by 4 factorial into 4 factorial into 4 factorial 6 times, which is 4 factorial to the power 6. But since this group size 4, 4, 4 is repeated 6 times, so I need to further divide it by 6 factorial. So do you not think that this is basically nothing but division of 24 objects into sizes of 4, 4, 4, 6 groups? And along with this, if the order is important, I'll multiply it by 6 factorial. I repeat, this is nothing but what? This is still alpha only. Are you getting it very clearly? This is still nothing but alpha only. Alpha only. Here, why am I stating this? It is the number of ways in which you can divide 24 objects into 6 groups of 4, 4, 4 each. Do you not think number of ways means a natural number? Number of ways means a natural number, a cardinal number, a countable number. So can I not say this will give you a number of ways? And number of ways means what? A natural number. So will I not conclude I am not able to calculate it, but still I can say that this is going to be a cardinal number, a countable number, which means a natural number. So can I not conclude that alpha will be a natural number? On the basis of this, can you not make a comment on beta as well? Let's try and work upon this. Did you get the hint? Now, to have beta, 120, 5 and 24. Can you not crack? 5 into 24 is 120. So hint is right there in front of you. So this time, let's say I'm dividing 120 into sizes of 5, 5, 5, 5 each. And how many such groups? How many? They are 24 such groups. So I'm creating 24 groups of 5, 5, 5 each. And basically 24 into 5 is 120. So there were total 120 objects initially. How will you do it? So the formula remains very simple. The formula remains very simple. The formula says total number of objects 120. So 120 factorial divided by sizes of the groups 5, 5, 5. How many? So they are basically 24. So instead of writing it like this, can I not write it as 5 factorial 24 times means 5 factorial to the power 24? Now, this group size has appeared how many times? This group size has appeared 24 times. So I'm asked to divided by the number of times a specific group size is appearing, which is 24 factorial. I hope you're understanding it. Now, let's say the order is important. The order of the group is important. So if the order is important, do I not need to multiply it by 24 factorial? Because 24 groups are there. So that arrangement will come into picture. So that is 24 factorial. What I am clearly seeing is that this is still beta. Because 24 factorial cancels this 24 factorial. This is what you are left with, and that's it, nothing but beta. But to me, this looks like dividing 120 objects into 5, 5 each into 24 groups and then distributing them into 24 groups where the order of the group mattered. So here in this case, this is again going to be a number of ways in which this can be done. This will be a cardinal number. This will be a countable number. And if it is a countable number, can I not say that beta is also going to be a natural number? Are you not realizing this is how easy it was? All you needed to do was look at the pattern, recognize the pattern. And if you are able to do it, if you know the formula of division and distribution, can you not do it? So here, alpha and beta both should be natural, which means option C. Did you get that part? Any confusion on that? Tell me honestly, how many of you were able to do it? How many of you were able to think like this? Do write in the comment box if you were able to think like this. This is what IIT expects, something out of the box, something really interesting. I'll say a very good question it was. Now, let us move ahead towards the next part. Here also, I'll say very simply, we'll discuss this particular concept through a question only. So don't worry about that. Yeah. Now, let us talk about, this is exactly what we'll discuss through a concept. So don't worry about it. I'll rather give you an example and make you understand through an example, a very standard example, which will give you a complete clarity. Let's say I have 10 identical chocolates. I have 10 identical chocolates, right? And there are students sitting in the class and there are 4 students sitting in the class, let's say, right? And let's say the name of the 4 students are A, B, C, and D. So in how many ways can I distribute these 10 identical chocolates among 4 students? My answer will be, sir, A plus B plus C plus D should be 10. So sometimes they say a word problem that 10 identical chocolates are to be distributed among 4 students. They put some constraints on it. We'll discuss about that later. And sometimes what they do is they give you a problem that the number of non-zero integral solutions, non-zero positive integral solutions of A plus B plus C plus D is equals to 10. I'll say, forget all this. Can you not do something really simple where I am asking you to write 10 in ones. So 1, 1, 1, 1, 1, 1. How many ones? 6, 7, 8, 9, 10. And these 3 plus sign. The number of ways in which I can arrange these 10 ones and these 3 plus signs will be the total number of solutions of this, which will be the total number of solutions of this problem. Here, there I am having 10 objects. So 10 objects can be arranged in 10 factorial ways. Divided by, sorry, these are not 10, 10 plus 3, 13. I'm really sorry. So there are total 13 objects. So 13 objects can be arranged in 13 factorial ways. Out of which 10 are identical. So 10 are of a type, which means 10 factorial, into 3 are of another type, which means 3 factorial. This is the solution. I hope you're understanding. Let's say one of the examples I'm trying to give you. Let's say 2 1s appear here, 1 plus appear here, and 3 1s appear here, another plus appears here. Let's say 5 1s appear here, right? And then one more plus appears here. So how is it going to be a solution here? It is indeed a solution because please understand, A got 2 chocolates, B got 3 chocolates, C got 5 chocolates, and D got 0 chocolates. I hope you're understanding it very clearly. So this is how you can create the solutions. But instead of thinking it like this, let me give you a formula as well, which will always help you. What was the problem? I was supposed to distribute 10 identical chocolates. So let's say n identical objects are to be distributed among 4 students. Let's say the number of people are R. So NCR minus 1, CR minus 1 will be the answer. Again, if you apply this formula, what does it say? N plus R minus 1. So 10 plus 4 minus 1, C4 minus 1. What is it? It is 14 minus 1, which is 13C3. And I hope you can see this is nothing but 13C3 only. So this is a logical approach. This is a formula-based approach. So I am asking you to remember this also as a formula, that whenever you are dealing with n identical objects and they are to be distributed among R groups, then it can be done in this manner. Will you remember it? Previously, the division or distribution we were doing of distinct objects. Now the problem is of identical objects. So when identical objects come into picture, this is what you should take care of. Are you getting it very clearly? Now, let us move ahead. Let us move further. Let us solve a question which will give us a great or a complete clarity of what I am trying to discuss here. It says the number of triplets x, y, z, where x, y, z are distinct non-negative integers. So had they not told you distinct, if they were not using the word distinct, I could have done it in seconds. But the problem is they have used the word distinct, satisfying the condition x plus y plus z is equal to 15. Now, how do we solve this problem? Let's say this distinct word was not there. Let's say for a while this distinct word was not there. So if this distinct word was not there, I'll say that it is a question of distributing 15 objects among 3 people. How will you do it? I think we have already learned the formula n plus r minus 1, c r minus 1, and the answer would have been 15 plus 3, which is how much? 18 minus 1, that is 17 c2. That would have been the answer, but this is not the question. This is not the question. Then what is the question? The question says that x, y, z, all of them should be distinct. They should be different. Now, how do you ensure that they remain distinct? That's a catch. Learning a formula and applying it easy. You can always do it. The logical approach should be there with you. That's the part here where you should put your attention. So first of all, let's say that if there was no constraint, if there is no negative, this part was not there, that you should keep them distinct, that condition was not there, the answer would have been simple, that 15 identical objects are to be distributed among 3 objects. So 15 plus 3 minus 1, which was 18 minus 1, 17c, 3 minus 1, which is 2. So if that condition was not there, my answer would have been 17c2. I hope you remember it, if there is no constraint. So this 17c2 includes which kind of cases? It includes the cases when all of them are distinct. It includes when all of them are distinct. It includes when 2 of them are identical, when 2 of them are same, or it includes when all 3 of them are same. So when somebody asks me that I need to keep I need to keep all 3 of them to be distinct, then I should exclude these 2 cases out of the total cases. Are you understanding the approach? Let's apply that thought. Let's apply that idea. So the idea says that here, let's calculate when x and y are same. So let's imagine that x and y are same. So if x and y are same, let's call them x only. So when x and y are same, the problem becomes 2x plus z is equal to 15. Right. The solutions are non-negative. Non-negative means what? 0, 1, 2, 3, 4, 5. So let's try x as 0. Can we keep x as 0? In that case, when you keep x as 0, z will become 15. Is that fine? I think there is no problem, because if z is 15, x will become 0 and x, y both will be 0. So when x is 0, z is 15. I hope you're understanding it. That is perfectly fine and acceptable. Now, let's look at the other case. Achha. If you're not getting this part, you have another choice as well. Let's think vice versa. Vice versa means, can I not say that here 2x would have been 15 minus z? I hope you're understanding it. What does it mean? It means that here, in order to keep this 2x, in order to have this x, you should have an odd value of z only. Third case, if you are not getting this particular fact, I'll give you a third scenario as well. The third scenario is, so far I think I had written x, let's say z. So what is z? Z is 15 minus 2x. So what you must understand is that 2x will be even. This is odd. Odd minus even will be odd. So what you should, by looking at this equation only, be able to understand that z will take only odd values. That will narrow down your problem to half. Why? Because please understand, if I begin with x as 0, z will be 15. Did you get that? If I keep x as 1, you can count it manually or you can predict the number of cases. See, if you keep x as 1, 15 minus 2 will be 13. So z will be 13. I hope you're understanding it. If you keep x as 2, so 2 into 2, 4. 15 minus 4 is basically 11. So z gives you 11. Are you understanding it? So if I keep x as what? 3, I'll get z as, I hope you have seen the pattern, 15, 13, 11. So it will be 9. Are you noticing it very clearly? Because 2 into 3 is 6, 15 minus 6 is 9. What about some more cases? Yes, there would be some more. What if I keep x as 4? In that case, 2 into 4, 8, 15 minus 8 is 7. So z would have been 7. Did you get that part? Can I keep x as 5? Let's try and do that. So if I make x as 5, I hope you must have understood the boundary condition, because the moment, I'll show you right. The moment x touches 7 or 8, then I'll have to be more cautious because x cannot be 8. I'll show it here. X is 5, then z is 5. I hope you see x is 5, then z is also 5. Logically, up till now, it is fine. Even with x being 6, 15 minus 12, which is 3, that is also fine. Even with this case here, when I take x as 7, that is also perfectly fine, because when x is 7, z will be 1. What I'm trying to make you understand is that all these 7 cases, all these 8 cases, I'm really sorry, all these 8 cases you would have been able to think by yourself. Why am I calling them 8 cases? Because x is 0, 1, 2, 3, 4, 5, 6, 7. Yes, they are 8 cases. What you need to understand here is that the moment I keep x as 8, I hope you must have started noticing the pattern. 16 and 15 minus 16 is minus 1, and that would have made it negative. So this case should be excluded. Did you understand this part? Did you all get this part? I hope there is no confusion on this front. So these are the 8 cases which we have seen here. But in these 8 cases, are you not noticing that this is a particular case where all 3 of them, x, y, z, all 3 of them are equal? Because x is 5, y is also equal to x, which is 5, and z is also equal to 5. So this case should be treated here in this case only. So shall I not say, if I had 8 cases, because we started with 0 and we reached 7. So we had total 8 cases. But out of those 8 cases, this is the case which does not belong to the case of 2 being same, because this is the case of all three of them same. So all 3 of them could be same. That is the one case, which is 5, 5, 5, 5. That I'll talk about later. But if 2 are kept same, it has 7 possibilities. It has 7 possibilities. But please understand, it has 7 possibilities when I kept x and y equal. Can I not say that there will be 7 more possibility when I keep y and z same? There will be 7 more possibilities when I keep x and z same. 7, 7, 7, 7 into 3, 21. So there will be 21 cases when 2 of them are same. xy, yz and zx. And there will be one case 5 by 5 in which all 3 of them are same. So when you are willing to answer 17C2, what is 17C2? It is 17 into 16 divided by 2. I hope you remember how to expand it. Minus the cases when 2 of them were same, 21 cases, minus the cases when all 3 of them were same. Only one case, 5, 5, 5. So these cases when subtracted will give you the final answer. Did you understand the whole approach? I'll still emphasize and urge and insist that please understand the logical approach. Please understand the idea. How should you do this? How should you imagine this? Because the more clearer you are with these mindsets, with the approach, you need not rely much on formulae. Formulae are there, which you can master with practice. But IIT JEE is not much interested in a brain which crames the formula, which mucks up the formula, which memorizes the formula. As you can see, witness it very clearly here. You must have seen the last example. alpha and beta, natural number. A brain which remembers the formula, which is good at memorizing, won't be able to solve those questions because they require logical mindset. The clearer you are with the concepts, the better clarity you have, the chances are higher that you will be able to solve them. Otherwise, you will get stuck. You won't be able to think like this. So, being able to imagine like this, being able to think like this, being able to solve these questions analytically, able to imagine these possibilities, you need a good logical brain, an analytical brain, a problem solver you need to be. Please understand that. So strive with the problems, delve with the problems. The problem with your generation is that you are very much relying on AI. And what AI is doing these days is that it is not letting you solve a problem. You are not doing much. Your brain is not putting efforts in solving a lot of things. And when you don't let your brain work, that's where you actually don't let your brain develop. What is the exercise for brain? Solve problems. The more you solve problems, the better you get with your brain, the better your brain develops. So for the development of your brain, you should solve a lot of problems. So when life throws problems at you, the problems which you don't deliberately create, which are created knowingly or unknowingly, mostly subconsciously or subtly, then try solving them. Don't run away from them, because the more you deal with the problems, the better you get with them, the better your brain develops, the more intelligent you become, the more logically sound you become. I hope you are getting it very clearly. Accept and embrace problems. That's the only way in excelling things. Failures, problems. I hope you're understanding my intent, my motive. Let's get back to our session. Solve a lot of problems. Don't avoid them. Right? Now, let's talk about the next case, dearrangement. There are multiple definitions. I'll say a very simple scenario here. When n things are to be placed at n specific places, but none of them is placed on its specified position. For example, let's say I have 5 friends A, B, C, D and E. I have written 5 letters, although you don't write letters these days, but let's say I've written 5 letters to them. So there is a letter for A, there is a letter for B, there is a letter for C, there is a letter for D, and there is a letter for E. So by using principle of inclusion and exclusion, we create the concept dearrangement, which I'll not prove right now, which I'll not derive right now, but I'll give you the formula. The concept of dearrangement says that the number of ways in which these 5 letters are given to these 5 people such a manner that A does not receive this one which it was supposed to receive, B does not receive the letter which B was supposed to receive, and C and D and E don't receive their respective letters. Of course, you would say, sir, there are 5 factorial ways in which this task can be done, but out of those 5 factorial ways, I'm excluding the ways in which A, B, C, D and E receive the ones which way they were supposed to receive. I'm not saying this will be only one case. There will be multiple cases, because let's say if A has received his case, his letter, but what if they don't receive? What if B and C receive but the others don't receive? So there are multiple possibilities. And that's where you need to consider the principle of inclusion, exclusion, inclusion, exclusion. I hope you remember that. So by using this principle of inclusion and exclusion, the formula of dearrangement gets created. So let's say I need to dearrange 5 objects. What is dearrangement? That those 5 letters should not reach at their respective places. So I'll use this formula of dearrangement. So for 5, I'll use the value of n as 5. So inclusion, exclusion, inclusion, exclusion till 5 terms. And of course, I'll begin with 5 factorial. That's the formula for dearrangement. Did you get that? Of course, here also I'll ask you to memorize certain terms. Dearrangement of 1, that is D1, D2, D3, D4, D5. 5 terms up to 5. Dearrangement formula should be memorized by you. The value of D1, the value of D2, the value of D3. How do I do it? Let's find D1. What will be D1 here, students? I hope the formula makes complete sense. So if I'm writing D1, it will be 1 factorial into, what will I get from here? 1. And then minus 1 upon 1, 1 factorial, which means up till this term. So this will be 1 minus 1. Did you get this part? It should be 1 factorial into 0, which is 0. I hope there is no confusion on it. I hope there is absolutely no confusion on it. What about D2? What will you say about D2? You will say about D2 as 2 factorial into up till this, up till this. I hope you are understanding it. So it should be 1 minus 1 plus 1 by 2 factorial. I hope you are getting it. So 1 by 2 factorial is 2. 1 minus 1 is 0. So 2 by 2 is 1. So that is 1. So this is how you find the values of D1, D2, D3 up till D5. You should have these at your fingertips. Did you get that part? So if I begin with this result, we know that D1 is 1. We have discussed it. No, D1 is not 1. Am I making any error here? What should be D1? D1 should be 1 factorial. And then minus 1 to the power 1 by 1, which is 1. So 1 minus 1, which is 0. And 0 into 1 should be 0. What is wrong? I think it is D2. No, yes. D1 we know, D1 was 0. Yes, they are writing D2 here. I mistakenly took it as D1. Yes. So D2 will be what? D2 will be 1. Yes, we and both. I mean, the data which is written on the panel and what I was saying is absolutely right. I just got confused. I took it as D1. It is D2 actually. So D2 is 1. I hope you can see it very clearly, as we have also calculated D2 as 1. Then look at D3. D3 is going to be 2. I hope you know how to calculate it, but I am asking you to remember it. D4 is 9. D5 is 44. Up till D5, you should have these values at your fingertips. Remember them. Remember them. Up till D5, D6. Right? Now, let us solve a question. So what does the question say? In 2023, they have asked 5 students have been allotted their seats as per their roll numbers. The number of ways in which none of the students sits on the allotted seat. None of the students. So it's a classical question of dearrangement. 5 students, they should not sit at their respective seats. In how many ways can that dearrangement be done? You will say D5. You will say D5. Now either you remember the value of D5 or you derive it. So D5 as per the formula will be 5 factorial into 1 minus 1 by 1 factorial plus 1 by 2 factorial minus 1 by 3 factorial plus 1 by 4 factorial minus 1 by 5 factorial. That's how you can do it. That's how you can find it. Did you get this part? I hope you are very comfortably understanding it. Even if you remember D1, D2, D3, D4, that's how also you can derive it. But I hope even if you forget this, this is how very quickly you can get the value of D5. Just you need to push this 5 factorial inside and you can get the result very quickly. Although if I could remember or I could make you recall, D5 was 44. So the answer to this question will be 44. Did you understand the question of dearrangement? How do they deal with questions on dearrangement? How do they deal with this particular concept? And how should you remember it? Shall I move ahead with this next concept? Multinomial theorem. Now, instead of explaining this multinomial theorem, I'll again take an example and give you a great clarity here. This example will give you the clarity through, or what you should do is the number of ways of getting a sum 16 on throwing a dice 4 times. On throwing a dice 4 times. Okay, so what do I want? I want the sum to be 16. Okay, so this sum should be 16. And how many times should I throw this dice? This dice should be thrown 4 times. So we want the sum to be 16. If I throw a dice, what are the possibilities I can create? So when I throw a dice, I can get 1, 2, 3, 4, 5 or 6. These are the possibilities when a dice is thrown. So what are the possible sums you can create? Sir, when another dice is thrown, that will also show 1, 2, 3, 4, 5. So with 1, that 1, 2, 3, 4, 5 can be clubbed. With this 2, those 1, 2, 3, 4, 5 can be clubbed. With this 3, 4, 5. So a lot of cases will be created. With 2 dices, it will be 6 into 6, 36. With 4 dices, it will be 6 to the power 4. So I cannot write all those 6 to the power 4 cases. And out of which I cannot pick the cases when the sum is 16. That's not what you do. And if that was what you're supposed to do, why are we studying this chapter, permutation and combination? Then what is the method? What is the idea? Multinomial theorem comes into picture. How should we use it? Let me create that sample space like this. See, on a dice, I can have either 1 or 2 or 3 or 4 or 5 or 6 as an output. Right. Now, the same dice is thrown 4 times. So this again will appear, this again will appear, and this will appear basically 4 times. This will appear 4 times. In this expansion, I'll be seeing a lot of terms. But am I not interested in those terms where the power of x is 16? See, let's say from first dice, I got 3. From second dice, let's say I got 4. From third dice, I got 6. So 6 plus 4 is basically 10. Plus 3 is how much? 13. Let's say from fourth dice, I got 3. So from this first expansion, I got x cube. From second, I got x to the power 4. From third, I got x to the power 6. And from fourth, I got x to the power 3. So if I multiplied them, I got x to the power 16. So all the possible cases when this alpha, beta, gamma and delta are giving me the sum as 16 will be my acceptable cases. That coefficient, because whatever is the coefficient of x to the power 16 is going to be there, that will be the number of ways in which I am having the 16 as the sum. Are you understanding the application of multinomial theorem, which we have studied in binomial theorem here in permutation and combination? So do you not think that if I could simply find the coefficient of x to the power 16 in the expansion of this will be my answer? Are you understanding it? So my idea will be find the coefficient of x to the power 16 in this expansion. Did you get that? Any confusions on that? First of all, before I start solving it, which we all can very easily, did you understand why did I do it? And what should you do whenever you encounter such category of questions? And how can you seek help from multinomial theorem to solve this category of questions? Did you get this idea very clearly here? Now, if I move ahead, if I proceed further from here, what do I have here? Just give me a second, everyone. So here, I'll take x common from all these terms, although you can begin with or proceed with this as well, but let me take x common from here. So if I have taken x common, x common, I'll have x to the power 4 outside. So when you have x to the power 4 outside, you're left with 1 x square until x to the power 5 whole raised to the power 4. I hope there is no confusion on it. And I'm looking for the coefficient of x to the power 16 in this. I hope you're realizing if I remove x to the power 4 from here, I can remove x to the power 4 from here as well, which means I need to look at the coefficient of x to the power 12 into this. Did you get my statement? So can I not say now, let's look for the coefficient of x to the power 12, in the expansion of 1 plus x square up till x to the power 5 whole raised to the power 4. Do you remember the formula for sum of n terms of a GP? I hope you remember. A into whole of r to the power n minus 1 upon r minus 1, or a into whole of 1 minus r to the power n upon 1 minus r. Do you remember that? So if I could use it, why? Because it is a GP. It is a GP of 6 terms where the common ratio is x. Can you see that? So here I am looking for the coefficient of x to the power 12 in the expansion of this, which I am writing as a, which is 1. Then 1 minus r to the power n, the number of terms are 6. I hope you are realizing it, upon 1 minus r whole raised to the power 4. I hope there is no confusion on it. There is a complete clarity on this front. Now, let me move ahead. Let me go ahead. Here, when I write it further, I am finding the coefficient of x to the power 12 in the expansion of 1 minus x to the power 6 whole raised to the power 4 into 1 minus x to the power minus 4. Right? Okay, that's great. Now, please pay attention to this particular part. We haven't learned the binomial expansion of a negative integral index, which is actually excluded out of your syllabus. But here, for the sake of solving this question, I'll just give you the formula which is needed here to solve this particular question. So the formula is, this is something which you can expand through binomial expansion. And here, when you deal with 1 minus x or 1 plus x whole raised to the power n, where n is a negative integral value, then how do you deal with it? Before we talk about the expansion of this, which we'll of course discuss, let us talk about this particular part, because through this, I'll be creating or developing what is needed to be brought from here. But of course, if you want to have a conclusion on this, I'll just simply give you this idea. Let's say we have this expression 1 minus x to the power, let's say n. Always remember that here n is a negative integer. In this case, let's say this is the case 1 minus x to the power n or 1 plus x to the power n. Then in that case, what you deal with is the coefficient here. The coefficient here which you need to bring into picture will be, please understand that coefficient is going to be n. I'm taking its negative value. So if it was negative, I'll take its negative value plus r minus 1 CR. This is going to be the coefficient of x to the power r. So I repeat, if I am looking at the coefficient of x to the power r, it will be minus n. Of course, let's say this is minus 4. Then I'll write 4 plus r, whatever the power of x I'm looking for, minus 1 cr. That will be the coefficient, and it all depends. And the sign also keeps on varying alternatively plus minus, so that sign can also be brought into picture with the value of r here. I hope you are getting it very clearly. No confusion on that front. Right. Now, let's get back to the result which we have discussed here. The only thing which you need to keep or take care of in mind is that if it is 1 minus x, then the general term is always positive whenever there is negative integral value or power or index. But if it is 1 plus x, the terms keep on changing, or alternatively, they keep on becoming plus minus. So here it is minus, then 1 minus x basically. So all the terms will be positive. So I need not introduce minus 1 to the power r here. But had it been 1 plus x, I should have introduced another coefficient here, 1 minus 1 to the power r. That is not what I'm worried about. Now, let me get back to this part. 1 minus x to the power 6 whole raised to the power 4. I want the coefficient of x to the power 12. Let's expand it through binomial theorem. What does binomial theorem say? Binomial theorem says that I'll have a first term which is going to be nc0, which is going to be 4c0, which is going to be 1 into this 1, which I need not write, and this minus x to the power 6 to the power 0. I hope you're understanding it very clearly, which is going to be 1 only. I hope you're realizing it. Then alternatively, I'll have plus minus sign. So with this minus sign, what will I have here? Next term will have nc1. nc1 will be 4c1, which is going to be 4 only, into 1 to the power 4 minus 1, which is 3, which I need not write, into minus x to the power 6. So this 1 has appeared here. And then x to the power 6, x to the power 6 whole raised to the power, x to the power 6 whole raised to the power this 1. Did you get this part? Because here x to the power 6 was 0. X to the power 6 whole raised to the power 0 was there. Now x to the power 6 whole raised to the power 1 is there. Another term I'll be having. The next term will be 4c2. Why plus? Because x to the power 6 will be squared. So minus x to the power 6 when squared gives you a plus sign. Of course, 1 when raised to any power does not make any changes here. But x to the power 6 to the power 2 and so on. But I am not concerned about the other terms. Why? I'll tell you the reason. But let me write this part here. 1 minus x to the power minus 4 here. Now, let me get back to the part which I was trying to make you understand. X to the power 6 to the power 2 is x to the power 12. What I'm looking for is x to the power 12's coefficient. So the upcoming terms will be even higher in x powers. So I need not bother about that. So I'll stop here. I'll not look for the terms further here. Now, if I look at this part, this one when multiplied by x to the power 12 from here will give me a coefficient. I hope you're understanding it. Minus this 4c1 when multiplied with x to the power 6 from here will give me another coefficient. And then this 4c2 when multiplied with the term with the power of x as 0 will give me the other x to the power 12. So if I am trying to find x to the power 12's coefficients, I'll be getting with this, this and this only. All I need to do is a little bit more cautious, because when I'm looking for the coefficient of x to the power 12, now my job is finding the coefficient of x to the power 12 in this, because into 1 will be done. Then finding the coefficient of x to the power 6 into this, that will be the other coefficient. And then finding the coefficient of x to the power 0 into this, because this is already 12, x to the power 12. Are you able to think like this? Are you able to create this scenario like this? Now, what I'm looking for is now 1 into coefficient of x to the power 12 in what? In 1 minus x to the power minus 4. 1 minus x to the power minus 4. What's wrong with this? Minus 4c1. Can I write 4c1 as 4? We know that 4c1 is basically 4 into x to the power 6 is already there. So now I'll find 4 into coefficient of x to the power 6 in, again, 1 minus x to the power minus 4. Plus, what is 4c2? 4c2 will be 4 into 3 upon 2, which is basically 6. I hope I'm right. 4 into 3 upon 2, which is 6. Plus 6 into, it is already x to the power 12. So I need to find coefficient of x to the power 0 in, again, 1 minus x to the power minus 4. And this will be the answer. Once you figure this out, this will be the answer. Now, the challenge is this, this, and this. For this, we already have this. How do we find the coefficient of x to the power r in the expansion of 1 minus x to the power n, where n is a negative index, integral index? Now, Let's use this particular result. Minus n plus r minus 1 CR. How do we do it? Please pay attention to this part here. 1 into coefficient of 12. I'll find these values here. Let me find the coefficient of 12. So if I'm willing to find coefficient of 12, the coefficient of x to the power 12 will be minus n, which is what? I hope you can see it very clearly. The value of n is minus 4. So minus n will be 4. 4 plus, what is r? I hope you can see r is 12 minus 1 c. R is 12. So this is basically going to give you 12 plus 4 is basically 16. 16 minus 1 is 15. So this is 15C12. And NCR is NC n minus r. So 15C12 can be written as 15C3. So this is going to be 15C3. So this is going to be 1 into 15C3. So I'll be writing it as 15C3 only. Did you get that part? I hope you're able to understand this. 15C3 minus. Now 4 into coefficient of x to the power 6. Now, how do you find coefficient of x to the power 6? I hope it's easy now. You need to replace 6 and 6 here. So, it is going to be 4 plus 6 minus 1. That is 10 minus 1, which is 9C6. Any confusions on that? 9C6 can be written as 9C3. I hope there is no confusion on that. So, here I'll be writing it as 9C3 plus 6 into coefficient of x to the power 0. Coefficient of x to the power 0. If I'm looking for coefficient of x to the power 0 in this, I think 4 plus 0 minus 1, C0. Did you get that? 4 plus 0 minus 1, which is 4 minus 1. So it should be 3, C0. I hope there is no confusion on it. And 3C0 we all know is nothing but what? 1. So if I wish to write a 3C0 here, I can write a 3C0 here like this. All you need to do is simplify this. Whatever value you get will be the final answer to this particular question. I totally get it. It was a lengthy question, a tricky question, but it must have given you a lot of insights. Not only about multinomial theorem, but also about how do you use multinomial in PNC, and also an obsolete concept which is not there in your syllabus, but still it can be used in solving a lot of questions. Did you get that part? If you have understood this result, let us move to the next part where we'll be discussing some geometrical problem. Again, rather than making you learn these formulae, all the list of these formulae will be provided to you, so don't worry about them. But I am not very much interested in making you learn these formulae. Rather, what I want you all to is understand them through these questions. For example, this question in JEE 2025, what did they do? There are 12 points in a plane. No 3 of which are in the same straight line. Brilliant. Except 5 points which are collinear. Okay. Then the total number of triangles that can be formed with the vertices at any 3 of these 12 points. Now please understand. Let's say I have not read this part except for the 5 points which are collinear. Then what do I know? Now look at this. This is a geometrical problem, but it can be solved through PNC. All you need to do is apply your logic. To form a triangle, what do I need? I need 3 non-collinear points. Because whenever I have 3 non-collinear points, I can form a triangle. So let's say all these 12 points are non-collinear. Although 5 of them are collinear, but let's forget that. So out of these 12, let's say if all 3 of them are non-collinear. So out of these 12, in how many ways can I choose 3 points? 12C3. The number of ways in which I can choose 3 points out of 12 points will be the number of triangles I can form. I hope you're understanding it very clearly. So you need not learn any formula, the formula which we have shown previously. Although we'll give you these notes at free of cost. You can click on the link given in the description and access all of this at no cost. But still, I am asking you to use your brain instead of learning all these formulae which a human brain cannot. All these formulae, no, you cannot. Even if you try to do so, you'll end up forgetting or getting confused. So try to stick to the basics, the core, and then apply your brain, apply your logic. As we have been mentioning, they ask you logical problems. So out of 12 points, 3 points can be chosen in 12C3 ways, which if I wish to expand, I can expand it as 12 into 11 into 10 divided by, of course, 3 into 2. Now out of this, the problem is I have mistakenly assumed these 5 points also to be non-collinear, which were not. So out of these 5 points, the number of triangles which are getting formed are actually not getting formed because these 5 points are collinear. So the number of triangles which I have assumed to be formed with the help of these 5 points are actually not getting formed. So do you not think I should subtract those triangles which I have additionally counted here with 12C3? Did you understand my statement here? So 5C3 is basically 5C2. 5C2 is 5 into 4 divided by 2 into 1. If I could simply solve this, I'll say that 3 into 2 is 6 into 2 is 12, and there you have 2 into 2 is 4. So this is going to be 11 into 2, 22 into 10, 220. 220 minus 10 is 210, which is option D. Did you get this whole part? Did you understand the whole approach? How easy these questions are and how simply you can deal with them. Now, once you have done this part, let us move to the next question. Again, a brilliant question asked by GMains in 2025. I'll give you a hint, although we'll solve it together, don't worry about it. But first, I'll give you a hint. You can pause the video then and try it by yourself. And then we'll discuss this question together. It says, the number of ways in which A, B, C, D can be placed in 8 boxes of the figure below so that no 2 row remains empty. So two rows must not remain empty. And at most one letter can be placed in a box. Tell me the total number of ways in which this can be done. So we have 8 boxes, out of which 5 are to be filled. So out of 8 boxes, 5 can be filled in 8C5 ways. This is the total number of ways. Did you get that part? Now what do we want? We want that no row remains empty. Now please understand, if I fill 3 here, then 2 can be filled here. This will remain empty. If I fill 3 here, 2 here, this will remain empty. If I fill 3 here and 2 here, this row will remain empty. So out of these total cases, can I exclude the number of cases when row 1 goes empty, the second case when row 2 goes empty, the third case when row 3 goes empty? So if I could simply exclude these 3 cases out of the total number of cases, will I simply not be left with the number of cases when no row is remaining empty? Because 2 rows being remaining empty is not possible at all. Out of 8, 5 are to be filled, 5 boxes are to be filled, then you will have to keep them in 2 rows at least. And 3 rows are staying filled, that is not a possibility. So out of total possibilities, there are 2 possibilities, category wise. One, at least or exactly 1 row is remaining empty, or no row is remaining empty. So if total possibilities, out of total possibilities, if I could remove those cases in which exactly 1 row is remaining empty, where R1 is remaining empty, or R2 is remaining empty, or R3 is remaining empty, if I could exclude them, I'll be left with the cases when no row is remaining empty. If you could solve that, I'll be really happy. So as of now, pause the video, do it by yourself, and then we'll discuss it together. Did you try solving this through the approach which you were told? If you weren't able to, let's look at this part. I hope you are very much clear with the selection part here. I haven't included the arrangement part so far, which we'll discuss later. But so far, if I were to select any 5 boxes out of these 8 available boxes, that can be done in 8C5 ways. But it includes those 2 cases segregated, broadly by this phenomena that either all the rows will be filled, or maybe 1 row could be empty. But you cannot have a case where 2 rows are empty. That's not possible, because you could have seen this possibility here. Now, can I talk about the possibility when first row is empty? So if the first row is empty, do you not think that in that case, I'll be having this, 5 boxes to be filled? So out of these 5 boxes, if I'm willing to fill the 5 boxes, that can be done in 5C5 ways. I'm not talking about the arrangement part, Abhi. I'm talking about the selection part only right now. So out of these 5 boxes can be filled in 5C5 ways. So those are the 5C5 ways in which I can have the first row empty. What about keeping the second row empty? Again, if I wish to keep the second row empty, I hope you can see 1, 2, 3, 4, 5. So 5 boxes can be chosen in 5C5 ways out of 5 boxes. So if I wish to keep the second row empty, I hope you are getting it very clearly. That can be done in another 5C5 ways. What about the third part? If I wish to keep the third row empty, again, if I wish to keep the third row empty, I'm left with 1, 2, 3, 4, 5, 6 boxes. So out of these 6 boxes, if I were to choose 5 boxes, it can be done in 6C5 ways. So these are the ways in which I'll have exactly 1 row empty. First row empty, second row empty, third row empty. So out of total cases, if I could remove these cases, if I could get rid of the cases where I'm having exactly 1 row, first row, second row, third row empty, then I am now left with the cases when there is no row which is empty. Did you get this part? Now, When you have done this, the second part is, let's say I have created a case where A, B is here, C is here, D is here, and E is here. Do you not think if I have chosen these 5 boxes in such a manner that no row is empty, do you not think that these 5 boxes and these 5 letters can be arranged into these 5 boxes in 5 factorial ways? So I need to multiply my entire answer with 5 factorial, because I have 5 factorial ways to arrange these 5 objects at 5 places. The arrangement has come into picture. So initially it was combination and then arrangement, which means the problem was on permutation. But how did we do it? A geometrical problem. Are you able to understand this whole part? And again, the simpler part, which I think is doable by you, you know how to expand 8C5, you know how to find these values, subtract and multiply, that is doable. The tricky part was to make you understand the challenge. How should you think? Are you understand? You should work on being able to think or solve problem logically. That is what permutation and combination asks you. Even there could be some other approaches as well to solve all the questions we have discussed so far, but still these are the ones which I am able to think of. And if you have any other approach, if you were able to think of some other approach, do share in the comment. I'd love to hear from you, because we all have something which the other person may not be aware of. Now let's talk about questions based on dictionary. I'll take a question and then share the example right there in front of you. For this category of questions, we can always have a short technique. Don't follow the standard method. Let's say there is a word Monday. There is the word Monday, right? So there we have a word Monday. And the dictionary based question says that all the possible permutations, all the possible arrangements of the word Monday are arranged in a dictionary as per the dictionary. Then what will be the rank of the word Monday? Whenever you're asked a question based on rank in a dictionary of a particular word, I'll share a standard technique, a shortcut I'll say, and through that you can find the answer within seconds. What is that short technique? Let's talk about that. Let's say I am willing to find the rank of Monday. Let's find the index of these letters as per the alphabet. So first of all, I'll have A. So A is your first letter. Then A, B, C, D is your second letter. E, F, G, H, I, J, K, L, M, N, O. So M will be third, N will be fourth, O will be fifth. And of course, ultimately, in the end, I'll have Y, which is the sixth letter as per this index. So alphabetically, this will be the order. Once you have arranged them like this, so M, O, N, D, A, Y, they'll have their indexes like this. So if let's assume that our alphabet has only these 6 letters. So as per the alphabet, A will be the first one, D will be the second one, M will be the third, N will be the fourth, O will be the fifth, and Y will be the sixth letter. So out of these 6 letters, if I create all the possible arrangements, where will you rank Monday? There is a short technique, and that is what we are going to discuss. How do we do that? Please understand. Now, the short technique says, hold this 3, and on the right of 3, give me the numbers which are less than 3. So 3 is there. Less than 3, it is 2 and 1. So how many numbers are less than 3? 2. So write a 2 here. Did you understand what I'm trying to say here? Look at this 5. On the right of 5, look for the numbers which are less than 5. So 1, 2, 3. So there are 3 numbers which are less than 5 on the right of 5. Hold to this 4, hold this 4. Now on the right of 4, I could see 2 numbers which are less than 4. Now look at this 2. On the right of 2, I can see only one number which is less than 2. Stick to this 1. On the right of 1, there is no number which is less than 1. And 6, there is nothing on the right of 6, so I'm left with 0 here. Did you understand this part? This is the short technique I'm sharing. I'm not sharing the longer approach because it won't matter at this stage. Just learn this short technique and get the answers of your JEE Means questions. Now, the next funda says here you begin with 0 factorial, 1 factorial, 2 factorial, 3 factorial, 4 factorial, and 5 factorial. This is what you do. You begin with 0 factorial, 1 factorial, 2 factorial, 3 factorial, 4 factorial, and 5 factorial. Right. Then what you do is you multiply this 0 to this 0. You multiply this 0 to 1 factorial, 0 to 0 factorial, 0 to 1 factorial, 1 to 2 factorial, 2 to 3 factorial, 3 to 4 factorial, and 2 to 5 factorial. And then you add all these products and then you add all these results. Did you get my point? So when you do this, I hope you are realizing this will be added to this result plus, I hope it is understandable, it is not getting confusing. This will be added to this result plus this will be added to this result plus this will be added to this result plus this will be added to this result. Most of you must have noticed it very clearly that, sir, here 0 into anything, 0 into thing won't matter. So I'll begin with this part. 1 into 2 will be 2. 2 into 6 is basically 12. I hope you can see it very clearly. 3 into 24. I hope you realize this is 24. 24 into 3 is 72. So this is 72. 5 factorial is 120. 120 into 2. 122 is 120 into 2 is 240. I hope there is no confusion on that. And to that sum, you add 1. What does it mean? Before this one, these many letters, these many words will appear. So Monday will have these many words before Monday plus 1 rank. Because Monday's index will be plus 1. So these many words will appear before Monday, plus 1 will be your answer. So what does it mean? It means if I add 240 to, let's say, 72. So 240 plus 72. 240 plus 60 is 300. 300 plus 12 is 312. 312 plus 12 is, I think, 324. 324 plus 2 is 326. 326 plus 1 is 327, and that's your correct answer. Did you understand the whole approach? Did you get the whole idea? Were you able to think like this, the short technique? I hope you will remember it now. You won't forget. So that's the idea. I hope there is no confusion on this part. How did we do it? The entire approach. Now, there is another category of question where your shortcut doesn't work, where you have to follow a certain ideology, certain mindset, certain set of rules or principles. What is that? Let's have a look at that. The words with or without meaning made using all the letters of the word Kanpur and arranged as in a dictionary, the word at 440th position in this dictionary will be. Okay. What is the word? The word is Kanpur. What is the first letter in Kanpur? I mean, as per the alphabetical index, it will be A. Then after A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U. So these are the 6 letters of Kanpur which I have arranged in the alphabetical order. A, A, N, P, U, R. But alphabetically it will be A, B, C, D, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U. Did you get that? Did you understand it? Now, I am asked that which letter will appear at the 440th position, which word will appear at the 440th position. Now, by looking at the options, I can very clearly see that it will start with PR, 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 PR. So KN will be the next letter in the third letter, but PR is what it will start with. So why can I not directly reach until P? So see, if I am creating 1, 2, 3, 4, 5, 6 letter word, please understand what I'm telling you here is that all the letters which are starting with A will have 1, 2, 3, 4, 5 choices. So 5 letters at these 5 places can be arranged in 5 factorial ways. So with A, I'll have 5 choices. With after A, I'll replace K here. With K also, I'll have 5 choices. Even for N also, I have 5 choices. Even for P also, I'll have 5 choices. So 5 factorial into 5 factorial plus 5 factorial plus 5 factorial plus 5. It is appearing 4 times until you are having this P. I hope you're getting it. So before I write P, let me stick to this P now. When I stick to this P, before P, I had A, K, and N here. And each of our A, K, and N, I had 5 factorial choices, which means 5 factorial for each, which means 5 factorial into 3. 5 factorial we all know is very clearly 120. 120 into 3 should be 360. So that value I'm writing here. So I have reached till 360. I need to reach 440. So I'll keep a track or a count of it that now I'm left with 40, 40, almost 80 more words. So I think that will fall into this only because this P will also give me 120 choices. So 360 plus 120 would have been 480. 480 is more than 440. So that letter will be with P only, will start with P only. Now, let me go to the next part because looking at the options only, I'm getting the idea that it will have R at the second index. So before I reach R, how many choices do I have? So when again I start with P, here I have how many choices? I can have A here, then I can have K here, I can have N here, P of course I cannot have, and then I'll have R here. But before I push R here with this A, K, and N, I'll have, for A, let's say, I have 1, 2, 3, 4 choices. Did you get my point? So 4 choices means what? 4 factorial. 4 choices means what? 4 factorial. So if for A, I have 4 factorial choices, I hope you're understanding. So after A, I'll have K and then I'll have N. So for each three of them, I'll have 4 factorial choices each, which means 24 into 3. 24, I hope you can see it, 24 into 3, which is 72. So far, I think I'm very close to 440. I'm very close to 440 because 360 plus 72, I have reached to an extent. I have reached to an extent where A, K, N are over, and now I'll reach to this Rth index. I hope you are very much comfortably understanding this particular part. So 360 plus 72. So far I'm done with this. Now I'm beginning with R. 360 plus 80 would have been 440, I think. So this is 8 less. So this is basically, so far, this is accumulating to be at 8 less than 440, which is 3. It's not 3. 432. Did you get this conclusion? Now I need to travel 8 more places, right? So to travel 8 more places, I think these 3 is what I should play with. So after P and R, I think what should be the next letter? Since we have fixed P and R, the next possibility could be, let's say, A. Could be, let's say, A. But when I fix A, I think none of the options are having A. So options are having either K or N. But let's say if I again fix an A here, how many choices do I have? The number of choices I'm having is 1, 2, 3, 3 factorial. So with this 3 factorial, when A is fixed over here, this is the one case for this A. 3 factorial means what? 6 choices. So for this A, I have added 6 more choices. So 432 plus 6 will lead me to 432 plus 6 will lead me to 438 choices. I hope you're getting it very clearly. Now after A, what am I now left with? After A, once you have fixed, once you have, tried all the possibilities with A, I hope you're again going back to K. So I think it will be K now. So K is going to be fixed. So I think PRK will be my answer, option either B or C. I need to discard A or D. I hope you're getting it very clearly. Now, between A and D, between B and C, now this is what we have. I hope there is no confusion on this front. You are able to understand this particular part very clearly. With this K, now I'll be, so far all the possibilities have ended. This is the 439th word, whichever is going to start with K. So if I'm starting something with K, let me write the 439th word. Because before K, when A was here, I have created 438 possibilities. I hope you're getting my logic, my point very clearly. So with this 439th word which I'm going to create will have K, then all the letters alphabetically. So if I'm writing 439th word, what would that will be? PRK is fixed. And after K, if I again begin with this A, then after K, I'll have this N, then P is used, R is used, then U is used. So PRK, A and U will be the 439th word. So PRK, A and U will not be the answer because it is the 439th word. So if you are interested in 440th word, which you are left with only option C, and if you don't, even if you don't agree with me, then PRK A is fixed. You can swap this, so it will be UN. So PRK AUN, that will be your option C. I hope you are right. PRK AUN, and that will be the 440th word. So did you understand how did we calculate it? If you are able to think it logically, I think you can crack it. So this is the method, this is the approach, this is the idea, this is how you begin with. And of course, in IIT JEE, if you are given the options, why do you not seek help from the options? Did you understand this part? Let us move ahead. Let us go ahead. So this is it. That's all. That's all in PNC. My motive in this particular one shot of PNC was very simple, to give you clarity on conceptual learning. Formulae are there, the core, the basis is there, the standard principles are there of counting. But you should remember that you should have your logical approach. If you are logically sound, you can crack a lot of questions. Because this chapter is one of those chapters which asks you to be more logical, which asks you to open or explore avenues. And I hope you know, Elevate JEE Crash Course is the program in which we are providing you all these one-shots at absolutely free of cost. You can watch all these videos on our YouTube channel, and along with this, we are also giving you the DPPs for your practice in the real-time environment, and of course, the handwritten notes, these notes. at absolutely no cost. You can access the DPPs and the notes on our application, the PW application, link to which is given in the description. It will redirect to your app, to our app, which is the amazing platform from where millions of students are preparing for different competitive exams at affordable prices and getting the desired results. With that, I think we have gotten a complete clarity on this chapter. Let's meet in the next video where we'll be discussing more things. Thank you so much. You have been a great audience.